All right, so the goal for today is to review for your upcoming exam, which is tomorrow at 5:30 p.m. Yay. So, this is what we got going on here. And what I did was I pulled out the fall 2018 exam. And I wanted to go over this thing in every detail. I'm not going to skip a problem. I'm going to do every problem on here, whether you know how to do it or not. It's good practice. But don't let this be the only exam you guys look at. Look, you got 3 good hours to do this exam, but we've had all semester long to throw material at you guys. So there may be some things on this guy that is not, well, that wasn't on this exam, but may be on your exam tomorrow. So you want to make sure you go back some other exams and practice. Like, for example, limits of those exponentials, you know, those indeterminate forms of 1 to the infinity, 0 to the infinity, things like that. You know, the last exam that I covered for my class, that wasn't a problem on those things. But maybe there's a problem on this one. So you basically want to make sure you practice. And when you look at this thing, you want to make sure that you're looking at it from a studied perspective. Because look at it from formulas, look at it from application problems, especially word problems. You know we're going to hit you hard in terms of related rates and optimization. Those are 2 major concepts on word problems we hit you hard on Calculus 1. All right? So you want to make sure that you do several of those problems because you never know what kind of shape or diagram or whatever they're going to give you guys. So let's take a look at this thing and actually do the exam. Now, first things first. When it comes to exams, here's the deal. And this is for all professors. So I got a lot of folks in here that you got that are mine, but I also have a lot of folks in here that aren't my students. It doesn't matter which professor you guys have. Here's the rule. Do not email your professor. Do not call your professor. Do not harass your professor. Do not attack him in the parking lot. Do not do anything. We do not know what your grade is. It takes about a week we got 2,000 some odd students taking Calculus 1. It takes about a week because this is a common exam. Everybody gets the same exam because we're checking out data up on the particular exam. And so we look at that data before we actually publish that to you guys to let you know how you actually did on the exam and stuff. So honestly, it takes about a week. So if you take the thing, 5 days, I would say. So if you take the exam on Friday, it won't be until next Wednesday at the earliest that I will actually have some exam results. You'll know it when your professor, and if I'm your professor, when I put it on your Canvas site. I'll put it into that little column. You'll know. And then all of a sudden, there's a bunch of things that are going to change. And do not freak out when the Canvas gradebook gets turned off. We have that kind of power. It's incredible. We will hit a button, and it turns it off. And then all of a sudden, you start freaking out because you can't see your grades. You know why? Because we're doing this continuous upload, download stuff, and we don't want you guys to see stuff and get all upset about grades when something half uploads and stuff like that. We're going to make sure the entire system's working before we open it up and let you guys see the final exams and stuff like that. Because remember, the final exam by departmental and university law is worth 30% of your grade. That's a whopping amount. So it's going to affect your average in a big way. My goal is to make sure it affects it in a nice positive way. That's why we're doing the review on this thing. All right? So the exam is in 3 parts. The first part is multiple choice, no calculator. No one's allowed to use a calculator for the first hour of the exam. After the first hour, if some students are not done with this section, we will say, I'm sorry, you have to turn it in, and automatically pencils down, I don't care what you bubbled in or whatever, at 1 hour, part 1 is done for you. You'll get part 2 and part 3 and go back and continue to work. Your professor will tell you after that first hour, after everyone has turned in part 1, after that fact, they will announce when calculators will be allowed. But most of you guys are going to finish up this part 1, honestly, on average, is 35, 40 minutes. That's on average. Now, some people will take up to 50 minutes, but you only got 1 hour to do this thing, okay? Take your time. You've got plenty of time on this exam, okay? Just don't sit there for, 20 minutes doing one particular problem or whatever. Sit there and, get it, know your stuff, and get through it and stuff like that. But there's going to be some problems that take a little bit longer. Some problems are going to be rather short. Most people are done with the entire exam between 2 and 2.5 hours. But you've got 3 hours to do a common exam, okay? And for my class, I told my students to be there. You know, the last exam, just the exam before ours, ends at 5 o'clock. So a few minutes after 5, go ahead and get to your exam room. Get your seat. Get yourself set up. I will be organizing my class in terms of sections because I got multiple sections in classrooms and stuff. But I'm automatically, before even the exam starts, I'm going to start passing out some stuff because you got a lot of stuff to fill out. You got to fill out the OpScan sheet for part 1. You got to bubble in your name. You got to bubble in your 800 number, so don't forget to bring your ID card. So, and then for 5:30, I'm going to say, open your test booklets. And then we shall open our text booklets. Now, so here's an exam from a year ago. You know, you are supposed to put your name, last name, first name, your student ID, your professor, and what section you're in. And we always keep up with this stuff. So right now, assume it's 5:30. We open the test booklet, and we start doing the problems. Now, this is part 1. No calculator. What kind of problems do you think they're going to give you guys on a no calculator section? It mainly is going to be derivatives. About 60% of it's going to be derivatives. The other part of it's going to be limits, and don't forget the famous L'Hopital's rule, because this is a final exam. We expect you to use your knowledge on all that you've learned and stuff. And there's maybe some application problems, some of that. And just because you don't have a calculator doesn't mean we're not going to make you calculate something or other. But the numbers are going to be relatively easy that somebody in the 3rd grade should be able to handle. All right, so here it is. Look at this first one. F of x is equal to 3x squared minus 2x plus 1. Evaluate f prime of 1. Like I said, we got to take derivative of it and then plug in 1. Now, you are going to be plugging in some numbers into this thing. Just because you don't have a calculator doesn't mean you can't do it. So here we go. So the first problem is, I'm going to take my derivative. And usually, we start out with the first problem is something relatively basic. It's easy into this thing. Don't worry, we'll slap you upside the head on these other problems later. This one's kind of nice. What do we got here? 3x squared. Derivative of that is what? 6x. Minus derivative of 2x is 2, and derivative of 1 is 0. Therefore, f prime of 1 would be 6 times 1 minus 2, which is 6 minus 2, which is 4. The answer is B, 4. Now, when I'm doing these kind of problems, I'm going to treat every problem like it's a free response question. Because you never know what's going to be on the free response. So when I'm doing the exam for you guys, I'm going to try to be somewhat neat. I'm also going to be writing it up that is the way I would expect it if it was on a free response. This is the work I would expect to see. Now, yes, being multiple choice, I can be a little bit more sloppy. We don't grade your work, we grade the answer. But because this is a review, assume this problem was on the actual free response part where details count. This is what I would expect to see. Look at the next one. Big F of x is equal to 16 divided by x squared. Your job is to find big F prime of 2. All right? First thing you do, any kind of problem, before you take its derivative, is what we call John's fundamental rule of calculus. John's fundamental rule of calculus is very simple. It's better to clean up your algebra before your calculus than afterwards. Clean it up first. I don't like fractions when I have a variable in the denominator. I like to bring that variable to the top. So my function ends up becoming big F of x is equal to 16x to the negative 2. Now, take your derivative. Big F prime of x would be equal to negative 2 times 16. That's easy math. That's negative 32. X to the subtract 1. That would be negative 3. Now let's clean that up. So big F prime of x would be equal to negative 32, but again, a negative exponent, when you clean it up, goes back to the denominator, and that becomes over x cubed. But that wasn't the question. The question is, what's big F prime of 2? This will imply that big F prime of 2 would be equal to negative 32 divided by 2 cubed. That would be negative 32 over 2 cubed. That's right. Don't have calculators. 2 times 2 times 2. That's 8. And negative 32 divided by 8 is negative 4. Yes, we expect you to have some basic math knowledge here. So the answer is negative 4, and the answer is C. Yeah, question? No, not really. It's just basically what they call the power rule. The derivative of x to the n is nx to the n minus 1. You only use that quotient rule. I mean, I could use a quotient rule if you wanted to go back here, but since the numerator's a constant, just bring that sucker off the bottom to the top. Makes it a lot easier to take derivative of. I mean, if you did the quotient rule, drew the top is going to be 0 times the bottom. The whole term cancels. I mean, you could do it that way, but it's going to be an awfully long trip to be able to get the answer and stuff. Clean it up first, helps you out. Bring that stuff off the bottom to the top. Makes it a very simple, basic power rule to take derivative of. Now, the next one, however, again, told you, we're taking derivatives, but they're still making you evaluate. Look at this dude. H of x is equal to the square root of 5x squared minus 1. Find h prime of 1. Well, before I find h prime of 1, I want to find h prime of x. And before I find h prime of x, I want to clean up h of x. I don't do square roots. What's the square root also known as? Half a power. So that's 5x squared minus 1 to the half a power. So again, we're trying to review here, so I'm going to ask you guys some questions. What rule would I use to take derivative of this thing? Chain rule. Derivative outside, inside stays the same time derivative the inside. So you derivative outside, the 1/2 pops out front. The inside, 5x squared minus 1 stays the same. Raise 2, subtract 1, negative 1/2. Derivative outside, inside stays the same time derivative the inside. The derivative of 5x squared is 10x, and the derivative of minus 1 is 0. Now, before I find h prime of 1, I'm going to clean this guy up. And let's see here. 2 goes into 10 5 times. So this is going to give me h prime of x being equal to, let's see here, this will be 5x divided by, now this is a negative exponent. Negative exponents, when you clean them up, go back to the denominator. It's a half a power, which makes it a square root. So it's the square root in the denominator of 5x squared minus 1. Does that make sense? Now, find h prime of 1. Now you start evaluating this guy, plugging numbers in. This will be 5 times 1 over the square root of 5 times 1 squared minus 1. Now, yeah, we're going to make you plug in numbers on this stuff, but they're not going to be too deep. Look for easy numbers to crunch out. We're not going to make you calculate something out to the 14th decimal place or anything on a no calculator section. It's easy math. 1 squared is 1, times 5 is 5. 5 minus 1 is 4. So that'd be 5 times 1, which is 5, over the square root of 4. The square root of 4 is 2. So the answer is 5 halves. So 5 halves, the answer is D. Does that make sense? You know we're going to hit you hard on trig. And there are 6 trig functions. Sine, cosine, tangent, secant, cosecant, cotangent. Make sure you know how to take derivative of all those guys. Derivative of sine of x is cosine of x. Derivative of cosine of x is negative sine of x. Derivative of tangent of x is secant squared of x. Derivative of cotangent of x is negative cosecant squared of x. Derivative of secant of x is secant of x tangent of x. And derivative of cosecant of x is negative cosecant of x cotangent of x. Things you got to have memorized for this exam. So, this guy here. G of x is equal to the tangent of 3x. This is going to be the chain rule because the trig is on the outside, the inside is the angle. And because anything other than x, it's going to be a chain rule. Derivative of the outside, inside stays the same time derivative of the inside. So, g prime of x would be equal to, well, what's derivative of tangent? What is it? Secant squared. The inside stays the same, 3x, times the derivative of the inside, derivative of the angle. Derivative of 3x is 3. Cleaning it up, you get g prime of x is equal to 3 secant squared of 3x, which makes the answer D. Does that make sense? Questions? Now, I told my students this yesterday, but I'd say about a third of the class today are students that aren't personally my students. But I want you guys to understand, when you guys take common final exams, especially common exams that are the multiple choice type, I mean, look, the fact is, everybody in this world makes mistakes, including us great professors. Absolutely. I make more mistakes. Ask my students. They'll let you know about it. But, yes, we all make mistakes. But the difference between me doing this stuff and you guys doing this stuff is very simple. I graduated. They're not going to take away my doctorate degree because I screwed this problem up. You don't graduate if you screw up. That's a huge difference. I had to go through this thing and make sure I got it right. And so in terms of my careless errors, identify where you typically make mistakes at and slow it down at that process. I was always real good at getting the answer. I was always really bad at picking them out of a lineup. So my multiple choice test grades were not the greatest in the world. And the sad thing is, if we go back and look at it, I had the right answer sitting right there, and I surely circled the wrong dude. don't make my mistakes. But you make probably my mistakes, maybe even a few more. Wherever you typically make your mistakes at, slow it down to that part. So when you guys watch me, I'll nail this answer. I will methodically go through each one to make sure I circle the right one. And even then, I'll make a goof one time. I did that the other day in class with one of the problems and stuff. So we all make mistakes. Just remember that. But you got to catch your making mistakes. That's the difference between A students and C students. A students caught their mistakes. C students didn't. Okay? Look at the next one. G of x is equal to e to the 2x plus 4x quantity cubed. Find g prime of x. All right. First, to find g prime of x, pause, hesitate, and ask yourself, what rule? What rule would I use to take derivative of this thing? Chain rule. Derivative the outside, inside, stay the same time, derivative the inside. So g prime of x would be equal to derivative the outside. The 3 pops up front. The inside, e to the 2x plus 4x stays the same, raised to the second power. Derivative the outside, inside stay the same times the derivative the inside. The inside is e to the 2x. Now, derivative of e to the x is e to the x, but anything else, e to a function, chain rule version of it. Derivative e to a function is e to the function times derivative of the exponent. So derivative e to the 2x is e to the 2x times derivative of the exponent, which is 2, plus the derivative of 4x is 4. So there's my answer. I would clean them up a little bit. So g prime of x would be equal to 3 e to the 2x plus 4x squared times 2 e to the 2x plus 4, which is, and double check methodically, got to have a 2 on that sucker on the inside, so the answer is C. Does that make sense? Questions? Don't be surprised by this question, because I guarantee it's going to be on your exam. Find the equation of the tangent line. Yep. To the graph of f of x equals 4x squared plus 2x minus 3 at the point where x equals 1. We're going to hit you probably 2 or 3 times with this question. Find the equation of the tangent line. So, to find the equation of a tangent line, you've got to use the point-slope formula. And what is your point-slope formula? Y minus y1 is equal to m times x minus x1. Anytime you need to, quote, find the equation of a line, point slope. Okay? Which means you got to have 2 things, a point and a slope. Well, they gave me x equals 1. That's half a point. So to get the y-coordinate would be f of that x-coordinate, f of 1. That would be 4 times 1 squared plus 2 times 1 minus 3. 1 squared is 1 times 4 is 4. 2 times 1 is 2 minus 3. 4 plus 2 is 6 minus 3 is 3. So my y-coordinate is 3, and I have a point 1, 3. So there's the point part. Now to get the slope of the tangent line. Well, you've been programmed by your professors. Here it is. We all know when you hear the word slope of the tangent line, what you're supposed to do. Take a derivative. So here we go. Let's take a derivative. But you've got to evaluate it at your point. But first, let's take derivative. Derivative of 4x squared is 8x plus derivative of 2x is 2, and derivative of minus 3 is 0. So to get the slope of the tangent line, that'll be f prime evaluated at the x-coordinate, which was 1, which will be 8 times 1, you with me, plus 2. And 8 times 1 is 8 plus 2 is 10. So there's my point, and my slope of my tangent line is my derivative evaluated at that point, x is 1, and I get 10. So now I'm going to use my point slope formula and plug in my data. It'll be y minus the y-coordinate, which is 3, is equal to the slope of the tangent line, which is 10, times x minus the x-coordinate, which is 1. Does that make sense? Look at the answers, though, before I finish this problem up. Once I got that slope of the tangent line being equal to 10, if I look at my multiple choice answers, which I typically don't look at until I finish the problem, but if I stop a little soon and look at it, I can let you know right now I got a 50-50 shot on this answer. There's only 2 answers that actually have a slope of the tangent line being 10. The answer is either A or E at this point. Does that make sense? So you can also do that concept when you come across a much harder problem, hopefully, that you get it down maybe to 2 answers, and then you may have to use some educated guess. Instead of just 20% chance of getting a problem, use what you know. You can narrow down some of the solution aspects of the questions and stuff. All right, let's finish this guy up. I'm going to distribute the 10. I get y minus 3 is equal to 10x minus 10. And then I'm going to add 3 to both sides. And that gives me y equals 10x minus 10 plus 3 is minus 7. There's my answer, which means the answer is A. Does that make sense? Look at the next one. On which interval is the is the graph of g of x equals x squared times e to the negative 2x increasing? Okay. Choose the largest interval possible there. Okay. So you're trying to figure out the intervals of where it's increasing at. My students know anytime you've got a math problem where they hear the words find the interval of, what are you going to do? Draw a number line. Now, for intervals of increase and decrease, it's a first derivative number line. For intervals of concavity, it's a second derivative number line. You with me? So this is intervals of increase, so I want to do a first derivative number line. So the first thing I want to do is take my first derivative. My function is x squared times e to the negative 2x. Pause, hesitate, and ask yourself, what rule? X squared times e to the negative 2x. What's my rule? Product rule. Drew the first times the second plus the first time drew the second. So, derivative of x squared is 2x. Drew the first times the second, e to the negative 2x, plus the first, x squared, times drew the second. The derivative of e to the negative 2x, being e to a function, is, chain rule version of it, is e to the function times drew the exponent. That would be e to the negative 2x times drew the exponent, which is negative 2. Okay? I'm going to clean this guy up. So this would be equal to 2x e to the negative 2x minus 2x squared e to the negative 2x. Now, before I actually go and find the intervals of increase and decrease and stuff, I got to find these critical numbers. You got to find your possible max min points. So I got to take my derivative and do what first? Set it equal to your favorite number, which is 0, and solve. Now, there's my derivative, and I cleaned them up for you. Set equals 0 and solve. Now, when you got multiple terms and you're trying to set equals 0 and solve, the trick is you want to factor. What do I have in common with this stuff? I can pull out a 2x. I can pull out an e to the negative 2x out of both terms, and I would be left with, well, I pulled everybody out of this term, so you got 1 for placement, minus the 2's been pulled out, the e to the negative 2x has been pulled out, but you pulled an x out of an x squared, which means you got an x left over. Does that make sense? I factored out what they had in common. Now, I'm going to set each factor equal to 0, and there are actually 3 factors. There's the 2x, there's the e to the negative 2x, and there is the 1 minus x factors. So I set each factor equal to 0, so 2x equals 0, e to the negative 2x equals 0, and 1 minus x is equal to 0. Divide by 2, I get x equals 0. There's 1. This one, e to the negative 2x equals 0. What do you got to do to solve for x? What kills off an e? Natural log. You would take the natural log of both sides, but when you do that, you're going to take the natural log of 0. All right, let's talk about our log properties. What are you not allowed to take log of? Zeros or negative numbers, right? So this does not exist because you would officially take the natural log of both sides, but that part does not exist. So there's no critical number out of this thing. Does that make sense? All right. And then over here, I would just add x to both sides, and I get x equals 1. So there are 2 critical numbers, 0 and 1. You with me? Which tells me that some of these answers that have 2 in them, I can probably go ahead and eliminate those guys because that's not my critical numbers. My critical numbers are 0 and 1. But to find that word interval, I'm going to draw myself a number line. Here it is, g prime of x. And I got 2 numbers on this thing. I got 0 and I have 1. Okay? Now, I've got to figure out what these numbers are. Now, this is a more advanced problem, but we're up to problem number 7 on this thing, so they got harder on me. What am I typically going to do to figure out if it's going to be increasing or decreasing? What am I typically looking for? Where inside each interval, where it's going to be positive or negative. Positive means it's increased, negative means it's decreased. So, I'm going to do test values. And so, here we go. I'm going to pick a number between negative infinity up to 0. I choose negative 1. So g prime of negative 1. I know what you're thinking. Well, geez, Dr. Taylor, you don't have a calculator for this. You don't need a calculator. Watch me. All we got to do is just figure out the sign of it. So I'm going to plug negative 1, and the easiest thing is to plug it into the factored form. Here's some tricks. That's what I'm trying to show you guys on the exam. Plug it into the factored form because it's easier to multiply it out. So when I plug it in, this will be 2 times x is negative 1 times e to the negative 2 times negative 1 times 1 minus negative 1. Okay? Now when I clean that up, this will be negative 2 e to the squared, and 1 minus negative 1, minus minus is a plus, that'll be times 2. I don't care what the number is. Just multiply it out. What's a negative times a positive times a positive? Negative. That's all I cared about. Negative. So this interval is negative. That's what you have to do. And I'm doing it without a calculator. This was part of your exam. Okay, we can do this, just takes a little bit longer. Now, pick a number between 0 and 1. Yeah, I pick a half. All right, so g prime of a half. So I'm going to plug in a half into this guy, and I like the factor form because all I'm doing is trying to figure out the sign of this thing. So this will be 2 times a half times e to the negative 2 times a half times 1 minus a half. That's going to be equal to, let's see, 2 times a half is 1, e to the negative 1, and 1 minus a half is a half. Now, e to any power, I don't care what the power is, negative or positive, is always positive because it's exponential, so it's always bigger than 0. So this is positive times e to the negative 1 is positive times a half is positive, so the whole thing is positive. Does that make sense? All right, now plug in something bigger than 1. I choose 2. So when I plug in 2 into my derivative, this will be 2 times 2 times e to the negative 2 times 2 times 1 minus 2. Okay, I'll blow this up for you guys in the back to see this thing. I really am plugging these numbers in. 2 times 2 is 4. E to the negative 2 times 2 is negative 4. And 1 minus 2 is negative 1. What's a positive times a positive? E to anybody is always positive. They're kind of testing on that. Times a negative. What's a positive times a positive times a negative? Back to negative again. So everybody in this interval is negative. Don't always trust that the signs always alternate. I can guarantee you that. So now that I got my signs on this thing, oh yeah, what was the question? Oh yeah, they wanted me to figure out where the interval is what? Increasing. And to increase, the derivative has to be what? Positive. And it's positive between 0 and 1. Does that make sense? So the answer is A, 0 to 1. This was a more advanced problem, especially without a calculator, but there's how you do it. Does that make sense? Questions? All right, take a look at this next one, and I'll leave it up there for you guys to keep copying here. Number 8. The graph of f of x equals x cubed plus kx squared plus 4x minus 5 has an inflection point at x equals negative 1. What's the value of the number k? All right, what do we know about inflection points? So this is how they ask you these definition questions. Inflection points is, how do you calculate it? What do? So you take the second derivative and do what with it? Set it equals 0 and solve. And that's what we're going to do. We're going to take the second derivative of this guy, and when we plug in x as negative 1, it should be equal to 0. Does that make sense? So, I need my second derivative. To get the second derivative, I got to go through the first derivative. The derivative of x cubed is 3x squared plus, remember, k is a constant. Derivative of kx squared is 2kx plus the derivative of 4x is 4, and the derivative of minus 5 is 0. That's the first derivative. Now the second derivative of 3x squared is 6x plus the derivative of 2kx, remember k is a constant, is just 2k, and derivative of 4 is 0. Now, because they said we have an inflection point at x equals negative 1, we know that f double prime at negative 1 has got to be equal to 0. And I'm going to use that. So f double prime of negative 1 would be 6 times negative 1 plus 2k, but that's got to be equal to 0. This is how I'm going to figure out what k is. So negative 6 plus 2k equals 0. I'm going to add 6 to both sides. That gives me 2k is equal to 6, and then I'm going to divide by 2, and I get k equals 3. The answer is 3. Does that make sense? Also, when I do, ask my students, any of my classes, I try not to skip any steps. Now, I know there's lots of professors out there because they're trying to cover so much material and they like to do it fast. And they will kind of get it down to this point and they go, clearly k equals 3 and move on to the next problem. But, you know, in my humble opinion, where most of my students will make their mistakes isn't the calculus. They had an awesome calculus professor. They know the calculus. They can't freaking do the algebra on this stuff. That's why I will take these problems and take it out to the extreme. Divide by 2, k equals 3 stuff. Because that's where most people make their mistakes. It's not with the calculus, it's with the algebra. So pay attention to where you make your careless errors at. All right? Take a look at this next guy. Let f of x is equal to the natural log of 4x squared minus 3 divided by 2x minus 1. Evaluate f prime of 1. Now, here's the deal. You know, I could just jump in with both feet and start taking rid of this dude. That's fine. Derivative natural log of x, 1 over x. Derivative natural log of function, 1 over the function times derivative of the function. And you could do that and spend an extra 5 minutes on this problem if you wanted to, but it is a natural log. And the one thing you should know about natural log is they got some wonderful properties. Multiplication turns into addition, division turns to subtraction, and powers get to go out front. In this problem, this is a quotient that you're taking the natural log of. It is division. So before you take a derivative of it, clean them up. What does division turn into? Subtraction. So here's an example of knowing stuff actually helps you out. So this is the natural, f of x equals the natural log of 4x squared minus 3 minus the natural log of 2x minus 1. Does that make sense? Now, they don't have powers on the outside, so now you can take a derivative, but it'll be a lot easier to manipulate. So f prime of x would be equal to derivative of natural log of x is 1 over x. Derivative of natural log of a function is 1 over the function times derivative of the function. So this will be 1 over 4x squared minus 3 times the derivative of the inside. Derivative of 4x squared is 8x, and derivative of minus 3 is 0. Minus derivative of natural log of 2x minus 1 is going to be 1 over 2x minus 1 times derivative of the inside. Derivative of 2x is 2, derivative of minus 1 is 0. So there it is. I can clean them up if you want me to. So this would be equal to 8x divided by 4x squared minus 3 minus 2 divided by 2x minus 1. But one more hoop to jump through. We want to find what f prime of 1 is. So f prime of 1 is equal to 8 times 1 divided by 4 times 1 squared minus 3 minus 2 over 2 times 1 minus 1. I mentioned to you before, no calculator section, but should be easy math in terms of the arithmetic. 1 squared is 1 times 4 is 4, and 4 minus 3 is 1. So this first part is 8. 8 times 1 is 8 over 1 minus 2 times 1 is 2 minus 1 is 1. That becomes 2 over 1. So that pretty much cleans up to be 8 minus 2. So f prime of 1 is equal to 6. The answer is 6. Does that make sense? Questions? Questions? All right, take a look at this next guy. Oh, told you, warned you about these limits. They're going to show up at you all the time. Here it is. Take the limit as x approaches 3 of x squared plus 2x minus 15 divided by x minus 3. First rule of limits, what do? Plug it in. You've got to check to see what kind it is. If it's an easy problem, plug it in. If you get a number, you're done. And you don't have to do anything. But we better double check it. So plug it in. This becomes 3 squared plus 2 times 3 minus 15 divided by 3 minus 3. 3 squared is 9. 2 times 3 is 6. 9 and 6 is 15 minus 15. And what a surprise there. It's 0 over 3 minus 3, which is 0. Only with 0 over 0 or infinity over infinity do I get to use my L'Hopital's rule. This is the L'Hopital rule problem. So L'Hopital's rule, I'm going to take the limit as x approaches 3 of the derivative of the numerator divided by the derivative of the denominator. It's not the quotient rule. Just derivative of the top over derivative of the bottom and then redo your limit. Derivative of x squared is 2x plus derivative of 2x is 2 and derivative of minus 15 is 0. divided by derivative of x is 1, derivative of minus 3 is 0, so it'll be over 1. So this is just a limit as x approaches 3 of 2x plus 2. And first rule of limits is plug it in. That'll be 2 times 3 plus 2. That's equal to 6 plus 2. The answer is 8. Here is another one. Now, don't get me wrong. If it's 0, 0, you can go back to chapter 1 and do algebra if you want to, but trust me, you've already gone through all the calculus. L'Hopital's rule is real powerful. You should use it. And here's another example of that. Take the limit as x approaches infinity of 9 minus 3x divided by x squared plus 9x plus 3. Okay? First rule of limits is plug it in, just to show you. That'll be 9 minus 3 times infinity divided by infinity squared plus 9 times infinity plus 3. Now, 3 times infinity is infinity, and 9 minus infinity is actually negative infinity. Think about it. Divided by infinity squared is infinity. 9 times infinity is infinity. Infinity plus infinity is a bigger infinity. Plus 3 is infinity. It's an infinity over infinity. Yeah, granted, negative. Negative infinity over infinity, but still infinity over infinity. 0 over 0 or infinity over infinity is L'Hopital's rule. So I'm going to apply L'Hopital's rule to this guy. This would be equal to the limit as x approaches infinity of, we'll take derivative of the numerator, divide by derivative of the numerator. Derivative of 9 minus 3x is negative 3. And derivative of x squared plus 9x plus 3 is, derivative of x squared is 2x, plus derivative of 9x is 9, derivative plus 3 is 0. Now I'm going to plug in my infinity. So this would be negative 3 over 2 times infinity plus 9. 2 times infinity is infinity, plus 9 is still infinity. Negative 3 over infinity. And here's the deal. When you have an infinity in the denominator, it doesn't matter what the numerator is, when the infinity is in the denominator, what's the thing going to go to? A constant over infinity is 0. The answer is 0. Don't get me wrong. If you've taken my class especially, you could look at this thing and go, oh, I remember that stuff from chapter 1. The degree of the top, which happens to be 1, is less than the degree of the bottom, which happens to be 2. And anytime the degree of the top is less than the degree of the bottom, the answer is always 0. You could have circled 0 and move on to the next problem. You're right. And you would have nailed this problem perfectly because it's multiple choice. But if this problem was put on a free response question, this would be the work we would have to see that. We can't just assume you know so much stuff and the answer is 0. No, you actually have to show us some stuff. So this is the work to show the problem. Does that make sense? All right, take a look at this guy. Oh, old differential here. Let y equal x divided by 2x minus 1. Evaluate the differential dy when x equals 1 and dx equals 0.2. Again, a reason why we go over these old exams and stuff is to remind you of formulas. What is the formula for the differential of y? The differential of y is dy is equal to the derivative of my function times dx, where x is my independent variable here. So, if I've got y is equal to, same thing as f of x, which is going to be x divided by 2x minus 1, I need to use y prime, or f prime of x. I need to take derivative of this dude. What rule am I going to use to take derivative of x divided by 2x minus 1? Quotient rule. Derivative of the top times the bottom minus the top times derivative of the bottom, all of the bottom squared. Derivative of the top. Derivative of x is 1 times the bottom, 2x minus 1. Minus the top, x times derivative of the bottom. Derivative of 2x minus 1 is 2. All over the bottom, 2x minus 1 squared. I clean that guy up, so my derivative is going to be 2x minus 1 minus 2x here over 2x minus 1 squared. The 2x is canceled, and I'm left with negative 1 over 2x minus 1 squared. Okay? Now, there's my derivative. So, by formula, when they ask for the differential of y is going to be equal to my derivative, which is negative 1 over 2x minus 1 squared times dx. So if they give you a problem and ask, what's the differential of y, this would be the answer. But they want you to jump through one more hoop. We're going to evaluate this guy when x is 1 and the dx is 0.2. And I got no calculator. Oh my goodness. Well, I think we could figure it out. Let's take a look when we plug in these numbers. So dy is going to be equal to negative 1 over 2 times x is 1 minus 1 squared times dx is 0.2. Well, let's do some bad arithmetic here. 2 times 1 is 2, and 2 minus 1 is 1, and 1 squared is still 1, so pretty much this gives you negative 1 times that 0.2. Don't hurt yourselves now. What's negative 1 times 0.2? Negative 0.2. And so the answer is negative 0.2. Does that make sense? The numbers should be nice. Don't freak out when you got decimals as an answer. All right, number 13. Find the general antiderivative. Antiderivative means the same thing as integration. That's that last thing we covered, section 4.7. So here it is. So to find the antiderivative of this guy, we're going to integrate 4 over x squared plus 3 sine of x dx. Now, before I integrate it, again, I want to remind you about John's thumb rule of calculus. Clean it up first. Now, 4 over x, that's a special guy. When you got 1 over x, the integral of 1 over x is the natural log of the absolute value of x. Now, remember doing antiderivatives here. But anything with a power, you don't want powers on the bottom. You want to bring them to the top. So this is the same thing as the integral of 4x to the negative 2 plus 3 sine of x dx. Now, here's the deal. Pause, hesitate, this is left brain, right brain. Leave the right brain alone, go after the left brain. These are antiderivative rules. Don't get them confused with derivative rules. Antiderivative rules, to integrate, you add 1 over add 1. Okay? So, 4 is a constant, leave it alone. The integral of x to the negative 2 is add 1. That'll be x to the negative 1 over negative 1. Add 1 over add 1. Plus 3 is a constant. And here's the $64 question. What is the integral or antiderivative of the sine of x? Very good. Negative cosine of x. And you know, and the integral and the d go away, and you have one big plus c. And this is what I told my students how to memorize it. Get those derivatives down. Derivative sine of x is cosine of x, and derivative cosine of x is negative sine of x. When you go in reverse, it's the same dude, but the sign changes. Since the derivative of sine is cosine, the integral of sine is negative cosine. The derivative of cosine is negative sine. Therefore, the integral of cosine is positive sine. When you go in reverse, it switches the signs. Therefore, since the derivative of sine is cosine, therefore the integral of sine is negative cosine. So cleaning this guy up, 4 divided by negative 1 is negative 4. X to negative 1 is over x on the bottom. Positive 3 times a negative cosine will be a minus 3 cosine of x plus c. And there's my answer, which is answer E. Does that make sense? Now, I have gone through all of part 1. According to the clock, it took me 45 minutes. But I want to give you guys the warning. I gave you deep explanation with great handwriting. So that sense, I could have done this a lot faster if I didn't have to tell you what I was doing. And I just wanted you to know, this is on average what most people will do, finish this thing up for part 1. So now I turned in part 1. I will turn in the actual form. I'm going to turn in the bubble sheet. Now every professor is different how they want to do it. For my class, I'm going to make you turn in part 1 with the OpScan sheet. You will pick up after that part number 2, another OpScan sheet, and part number 3, and you go back to your seat and you'll start working. These are with calculators, but still, you're not allowed to use the calculator until I give the official yoki dokie on it. Nobody gets to use a calculator until you get the official word, and that's 1 hour after you start the exam. Everybody has to finish part 1 within 1 hour. I have to collect those things, and everybody's got to have part 2 and part 3. Then I'll make the official announcement that now you're allowed to have your calculator. You'll see this mad dash, everybody diving underneath their seats to grab their calculators, and then they come back and then it gets calm after a while and then they start working on it, okay? But trust me, even though I got 15 or 20 more minutes left before I get to use my calculator, I can do most of this exam without a calculator. Let's take a look at it. And if I do need a calculator, and I don't have one yet, put a star by it, get as much work as you can done, then move on to the next problem and just remember to go back and finish it up. So here we go. Part number 2. So probably by the time you get to the first 2 or 3 problems of part number 2, then calculators will be allowed. But, so let's take a look at this guy. See if I actually do need a calculator or not. Look at this first one. Suppose that f is a continuous function and that f of 0 equals 2, f of 1 equals -1, f of 2 equals 1, and f of 3 equals 2. Then according to, oh no, they're quoting somebody, the intermediate value theorem, which of the following must be true? Okay? Well, geez, Dr. Taylor, I don't remember the intermediate value theorem. Well, tell you what. Let's just draw what we got. Let's see if we can figure it out, whether you memorized a bunch of theorems or not. Here we go. I got some points here. So I'm going to graph this thing out. So here's my little graph over here. F of 0 equals 2. So here's 0, so your y-coordinate is 1, 2, right there. Put a dot. F of 1 is equal to -1. So here is 1. The y-coordinate is -1. I'm going to put a dot. F of 2, there's 2 right there. We're back to being 1. So it's right there. 2, 1. X is 2, y is 1. And here, f of 3 is equal to 2. So over here, here's x is 3. And the y-coordinate is 2. So this is what we got. I got 4 points plotted for you guys. And they tell me it is a continuous function. You with me? So I got to connect my dots. So if I connect my dots, I got to go, I'm just going to very lightly straight lines. Connect them down here, connect them up here, and connect them over here. Now, they're actually using a different word here. Okay? Which, according to the intermediate value theorem, which of the following is true? F of x equals 0 may not have any solutions. F of x equals 0 has at least one solution, but may not have 2 solutions. F of x equals 0 has exactly 2 solutions. F of x equals 0 has at least 2 solutions. None of the above. All right. When the function is equal to 0 is basically what they're quizzing you on here. It's where it crosses the x-axis. So if I get this continuous and I just connect the dots, how many times has it crossed the x-axis? So far, twice. Right here and right here. So right now I have at least 2 answers, maybe exactly 2. So right now the answer is either C or D. I got it down to a 50-50 shot. The rest of these things are done. Does that make sense? Now, here's the deal. It's continuous, but I didn't say how wavy this thing was. So if I wanted to make this guy continuous, but really fancy, like throw some cosines and sines on that thing, you may get something like this. This thing's a waving and a waving and a waving and a waving and coming over here and waving. And I got to connect these 2 guys, and they're connecting somehow, but maybe they'll come in here and wave a little bit more and do something like that. Now, how many solutions do I have? It's still continuous. How many do I have? I'm guaranteed to have this dude right here and this dude right here, but because I dipped him down and came back up to get this guy over here, I threw on a couple of more solutions. Because of that aspect, what is the answer to this problem? The answer is D. You're going to have at least 2 answers and maybe more because you can make that sucker wave. Does that make sense? And that's really that intermediate value theorem, is the idea that you'll have at least, solutions. You've got to cross the x-axis because that's, these are going to be the points that, because it's every value between -1 and 2 up here is going to be taken on by your y-coordinates because you've got a continuous function. It's part of that intermediate value theorem stuff. Does that make sense? Okay. So do you understand? I didn't actually quote the intermediate value theorem, which talks about being continuous, and since all the values between -1 and 2 are going to be taken up, 0 has been taken up, and you had to go down and back up again. So you got at least 2. The minimum number is going to be 2, but if you throw some waves in that, still continuous, you can have more than 2. That's the at least 2 answer. All right, take a look at the next guy. Great problem, because it reminds you of a formula. Here it is. Find the linear approximation for the function f of x is equal to 2 plus x minus e to the negative 2x at a equals 0. Oh, by the way, did I use a calculator for this problem? No. Am I going to use a calculator for this one? No, let me show you. All right. When you hear the word linear approximation, also known as linearization, this is why you study these old exams. Go through, and you should have an extra sheet of paper beside you just to write down the formulas that you're supposed to expect to have memorized for this exam. Linearization is this formula. L of x is equal to f of a plus f prime of a times x minus a. But if you forget the linearization formula is the same thing as equation of tangent line. So if you get in trouble, just find the equation of tangent line. It's going to be the same answer. Okay? But this is the official linearization formula. So we want to basically find this guy, this L of x. So I've got a function here. F of x is equal to 2 plus x plus e to the negative 2x. First thing I'm going to do is I'm going to plug in 0 into it. That'll be f of a there. A is equal to 0. That'll be 2 plus 0 plus e to the negative 2 times 0. 2 times negative 2 times 0 is 0. E to the 0 is 1. So this is 1. And plus 0 plus 2, that answer is 3. So in my linearization, a equals 0. So that would be L of x is equal to f of 0 plus f prime of 0 times x minus 0. All I did was replace all the a's with 0. And f of 0 is 3. So L of x is equal to 3 plus, I need to find f prime of 0, and then I'm done. Before I find f prime of 0, yep, it's calculus 1. I got to take a derivative. So what is the derivative of 2? 0. Derivative of x, 1, and here it is. What's the derivative of e to the negative 2x? So derivative of e to the x is e to the x, but derivative of e to a function is e to the function times derivative of the exponent. So that'll be e to the negative 2x times derivative of the exponent, which is negative 2. Now I want to figure out what f prime of 0 is. So f prime of 0 is equal to 1 plus e to the negative 2 times 0 times negative 2. Well, e to the 0, negative 2 times 0 is 0. E to the 0 is 1. So this is pretty much 1 plus 1 times negative 2. That's pretty much 1 minus 2, which is negative 1. F prime of 0 is equal to negative 1. So I'm going to plug in a negative 1 here, and I'm going to clean this guy up. So my linearization equation is going to be 3 minus plus a negative is minus 1 times x is x. Also known as, if you rewrite this, that's the same thing as negative x plus 3. The answer is A. And basically all you got to do is just remember the formula. And if I got in trouble, I'll just go find the equation of tangent line. It'll give you the same answer. Y equals a negative x plus 3, and you won the game. Does that make sense? All right? Now this guy right here. On occasion, we will make you do the famous definition of derivative stuff. They didn't ask you to do that. They asked you to evaluate this guy. I want to remind you of something, brother. There's an easy way and there's a hard way to this problem. And 75% of you people are going to do it the hard way. Now, that's fine, but you'll probably end up screwing it up doing it the hard way because it's all a bunch of algebra. And we didn't give you much room, by the way, if you noticed this. We gave you just enough room to get these problems done. Okay? You can't have a scrap sheet of paper on the test. We will provide that for you if you need it. But I want to show you that there is enough room to be able to work the problem completely on this exam. So, here's what you need to know. It was a formula using the definition of derivative. F prime of A is equal to the limit as h approaches 0 of f of A plus h minus f of A all over h. This was a formula from section 2.1 out of your textbook before we introduced all these shorthand how to do the derivatives. This was the definition of derivative. So that guy right there is the same thing as the derivative evaluated quote at A, but A would be 2 here. So since I gave you this, the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h, you're supposed to know, hey, A equals 2, so that's the same thing as f prime of 2. So for me to evaluate this guy, all I got to do is find f prime of 2. It's knowing the formula. So here we go. They gave me the function. So therefore, f prime of x is equal to, what's the root of x squared plus 3x minus 1? Well, that would be 2x plus 3, agreed? And so f prime of 2 would be 2 times, plugging x is 2, plus 3. 2 times 2 is 4, plus 3 is 7. Yeah, the answer is 7, and I'm done. And I didn't do a bunch of lemon as h approaches 0 and fall a bunch of stuff out or anything. It's knowing the formula. This is the way we were expecting you guys to do it. Does that make sense? Questions? So you did, I mean, especially on a multiple choice problem, we typically don't want you to do a bunch of lemon as h approaches 0. That'll be more of a free response. We want to see the algebra on that. So this one is understanding this formula is this, and so to calculate where A is 2, so all I really need to do is to evaluate this guy, is take rid of this dude and plug in 2, and that's all I did. Take a look at number 4. All right. Which of the following functions are one-to-one? All right. This was a definition. A one-to-one function is a function that passes the horizontal line test. You guys remember the horizontal line test? First off, you know what a horizontal line is. I got to go with the basics here. What's a horizontal line? Which way? No, that's vertical, dude. That's vertical. That's why I wanted to check this out. Yeah, this is horizontal. This is the horizontal line test. Vertical line test was to test whether you had a function or not. A horizontal line tests whether the function is, quote, one-to-one. The reason for that is only one-to-one functions have inverse functions, okay? That was the reason why we studied this one-to-one, and it was from the horizontal line test, okay? So, which one of these guys is one-to-one? Which one's going to pass the horizontal line test? Well, let's draw them out here. Here's number 1. I got h of x is equal to the cosine of x between negative pi halves is less than or equal to x, which is less or equal to pi halves. So if I graph that out between negative pi halves and pi halves, well, let's see here. The cosine of negative pi halves, that's negative 9 degrees. That's the cosine is 0. The cosine of 0 is 1, something you better know. And then the cosine of pi halves is back to 0 again. Remember, it's a cosine wave, but we're restricting it, so it's only this part of the classic cosine wave. Does that make sense? But is it one-to-one? Horizontal line test. Remember, though, the classic line test. When a horizontal line intersects the graph at more than one spot, it's not one-to-one. A horizontal line for a one-to-one function can only intersect it at one spot. So how many places is this thing intersected? I would draw it a little deeper so you can see it. How many places? 2. One, or more than one, it's not. So this is not 1-1. So, okay, let's take a look at number 2 here. G of x is equal to x cubed, and they gave me the domain as pretty much all real numbers. Negative infinity is less than x, which is less than infinity. You guys remember what the x cubed graph looks like? Because I don't need a calculator for that either. You shouldn't. You passed high school. What's x cubed look like? Squiggly line. You got it. Looks like this. Is it one-to-one? All intersect one spot. So one-to-one, big old check mark. The answer is yes. This one's a no. This one's a yes. Number 3 down here. Now, if you need a calculator for this, just wait for it. You'll get eventually a calculator in about 3 more minutes or whatever. But here it is. F of x is equal to the natural log of x, and obviously being natural log, your domain is 0 is less than x, which is less than infinity. You guys remember what the natural log graph looks like? The natural log of 1 is 0, and a graph, because you can't take a log of a negative number, so you only care about between greater than 0, it looks like this. And as you get close to 0, it goes straight down. Here's your little y-axis and x-axis here. Make this stuff look neat. You guys are looking at this stuff. All right, so here it is. This is what your log graph looks like. Is it one-to-one? When you throw a horizontal line up there, how many places does it intersect? Only once. So the answer for one-to-one, it is yes. Big check mark. So the only ones that were one-to-one was 2 and 3. The answer is E. Does that make sense? Questions? All right. There are certain problems on this thing, even though I haven't used a calculator yet. Don't worry, I got mine at the ready right here. And here's one that I would actually use a calculator on. And I'm going to show you this deal in a second. All right, I gave a problem just like this on my last test for my students and stuff. Here it is. They gave you the derivative. Merry Christmas. The derivative of f is f prime of x equals 3 times x minus 1 squared times x plus 2 times x minus 3 squared. And again, I'm going to show you guys strategies on how to do this problem. Which of the following statement is correct? Look at the question. See, because you can't tell what the question is until you look at the answers. Relative max 3, relative max 2, relative min. So they're looking at maxes and mins here. So if I want to do maxes and mins, I want to find my intervals of increase and decrease, and when I go up and go back down, I got a maximum. If I go down and back up again, I got a minimum. This is how I tell when I got maxes and mins. So what I really want to do to this guy is draw my first derivative number line. Well, here's the trick. I'm going to graph this function here, f prime of x. So, and this, I'm finally going to use something or other with my calculator here. So let me go y equals and clear off this guy and start another problem here. Here it is. 3 times x minus 1. And again, if I got to this problem without access to a calculator, I would just wait, go on to the next problem, and then eventually come back and get to this problem. Don't just waste time on the test. Use your 3 hours to your advantage. So I'm going to graph this guy. Even I know it's the derivative graph, but that's fine. 3 times x minus 1 squared, so I need a squared there, okay? And then parentheses, x minus 2, close parentheses, and then other parentheses, x minus 3, and again, we're squaring that one. That one's squared and that one's squared. And I'm going to do a zoom 6 so everybody can see my picture here. It's a negative 10 by 10 screen. But it looks like my zeros are at 1, 2, and 3, and there it is. So I'm actually going to zoom in on that spot. So I'm going to hit zoom in, right there at the origin. And you can see, well, maybe I need to slide it over a little bit. So let me fix that because I want to see where 3's at for a second. So window, change the maximum like 4 or something like that, and we'll graph it. And here it is. Boom, 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 and it goes back up again. And I'm going to graph that guy. Here it is. So here's 1, here's 2, and here's 3. The graph was this. It went down, came up, and remember, these are multiplicity 2, so don't be surprised that the little parabolas right there at 1 and at 3. But then it comes back down, and then it comes back up and goes through, and then it comes over here and hits 3, and then goes back up again. So this is just a general sketching of my graph. You with me? Now, I want a number line. I want to find those intervals of increase and decrease. All the numbers I care about are 1, 2, and 3, because those are where my derivative is equal to 0 at. Now remember, this is the derivative graph. So when it's above the x-axis, the derivative is positive, and when it's below the x-axis, the derivative is negative. So over here, the derivative is negative because it's below the x-axis. And then when you get on the other side of 1, it's back to being negative again. Then when you pass 2, you're above the x-axis. Now it's positive. And then you get on the other side of 3, and it's still positive because it's above the x-axis. Now I've got my intervals of increase and decrease. So let's analyze it from the original function perspective. This is my derivative. When the derivative of a function is negative, that means my function is decreasing. Then I hit 1, and then it's decreasing some more. And that makes 1 nothing. And then after I hit 2, it goes down. I hit 2, and now it's increasing. It goes up. And what does that make 2? If you go down, hit 2, and go back up again. This is a relative minimum. And then I go to 3, and then I stop, and then I go up again. What does that make 3? Nothing. There's only one actual critical max-min point, and it happens to be a relative minimum, and it's at 2. X equals 2 is a minimum, and that's it. So that says max. Be careful. Min at 2. The answer is D. Does that make sense? Again, this is why we're doing these exams, just to give you guys some helpful hints on certain kinds of problems. Here's a great one right here to know a hint on. Number 6. F of x equals x squared plus 1 has a domain for x greater than or equal to 0. Then f inverse of x, the inverse of f of x, is equal to which one? All right, basically they're asking me, how do you find an inverse? Okay, so you got your function. F of x is equal to x squared plus 1. And all you care about is between x is greater than or equal to 0. x is greater than or equal to 0. So if I graph this guy, now we all know what x squared looks like. What does a graph of x squared look like? Parabola plus 1 shifts it up 1. And I don't really need a calculator for that. But you only graph it for x is greater than or equal to 0. So it'll be from 1 up this way. Is this a one-to-one function? Remember, only one-to-one functions have inverse functions, because if it wasn't one-to-one, the answer is not invertible. But because the domain was x greater than or equal to 0, is this thing one-to-one? Yes, it is. Yes, on the one-to-one. So the inverse function exists. And here were your steps on finding an inverse function. Change the function to y, so you get y equals x squared plus 1. Step 3, switch the x and y. That was your big step. Switch x and y. That gives you x is equal to y squared plus 1. And then you're supposed to solve for y. When you solve for y, that'll give you the inverse. So solving for y, I would subtract 1 from both sides. This would give me x minus 1 equals y squared. What kills off a square? Square root. So that gives me y is equal to the square root of x minus 1, and that is my inverse function. F inverse of x is equal to the square root of x minus 1. The answer is equal. Does that make sense? Just remind you of some stuff that may have been a while. Now, look at number 7 here. Suppose that f of x is equal to, they got this conglomerate piecewise function. -1 if x is less than 0. X of 0 is less than or equal to x, which is less than or equal to 1. 2x minus 1 for 1 less than x less than 2. X squared if x is greater than or equal to 2. Where is f discontinuous at? Now, here's the deal. On a piecewise function, you have possible breaks at the pieces. X is less than 0, then you pick it up again from 0 to 1. So your first break is at 0, possibly. Your second break is at 1. And your third possible break is at 2. It depends on whether they meet up or not. You know the easiest way to figure out this answer? I mean, I can sit there and do a bunch of limit definitions on this thing, but if you really want to see where this thing's going to be continuous or discontinuous, just graph the darn thing. All right? So that's what I would do on this problem, is just graph it. All right, here's 0, here's 1, here's 2, and I'll keep on going. Here's 3, and we keep on going down the road down there. Okay? And now I'm basically going to plug numbers into this guy. So I'm going to give myself even y coordinates. 1, 2, 3, 4, 5, 6. That's good. -1, -2. So here's the deal. When x is less than 0, so here's 0 right here. When x is less than 0, you get y, the function is -1. Here's -1 right here. So it'll be an open circle because it's not equal to, and it's horizontal because it's a y equals -1. So that's part of my function. And then I skip over with still now x is 0, I get x. Plug in 0 into x, you get 0. And then when I plug in x is 1, I get 1. So I get this little line right here. And it's equal to, so they're both filled in dots on this end, and it's a straight line. That's y equals x. Then my break again is at 1. I plug in 1 in the same. 2 times 1 is 2. Minus 1 is 1, so 1 is 1, and that would be the open circle actually touches that guy. So they're actually connected. And now plug in 2. 2 times 2 is 4, minus 1 is 3. So at 2 you get 1, 2, 3. So that would be up here someplace. Okay, and that would be an open circle. So this would be a different kind of a line up here. Make my big open circle there. And then from this, 2 squared is 4. 1, 2, 3, 4. So this is at 3 right here. So 4. So you get a skip right there. So that would be equal to. And I know this one because it's a parabola. So it just keeps on going like this. And all I did was plot this guy. By plotting it, I can see where the breaks are at. And I can also see where they're connected at. So where are the breaks? There is a break here at 0. This at 1, they're actually touching each other, so it's continuous. And the other break is at 2. So the breaks are at 0. So the discontinuous, and that was the question here, discontinuous at x equals 0 and x equals 2. So the answer is 0 and 2. Does that make sense? It's not a real calculus thing here, but the calculus actually is with the limit. If you want to do the limit from the left, limit from the right, and see that you don't get the same thing, that tells you it's discontinuous there. You can use the definition there, but for a problem like this, the best thing to do is to graph it. Now, back to some real calculus here. A particle is moving vertically. Its height above the ground at time t is given by h of t, and I'll write down equations here. H of t is equal to 3t squared plus 5t, where t is greater than or equal to 0. Information there. We're only talking about positive time. H is measured in feet. What is the velocity when the height reaches 100 feet? So this is a classic word problem. What is the velocity? Okay, so the question is about velocity. And how do I get velocity? I'm going to take derivative. H prime of t, which is equal to v of t, which would be equal to derivative of 3t squared is 6t, plus derivative of 5t is 5. There's my velocity equation, but the problem is I need time. And they didn't give me time. They want to know what is the velocity when the height reaches 100 feet. So the height, h, is equal to 100 feet. So to figure out the time, what I'm going to have to do is take the 3t squared plus 5t, which is my h of t equation, and I'm going to have to set that equal to 100 to figure out the time. Does that make sense? Now, if you look at this equation, 3t squared plus 5t equals 100. This is a quadratic. Okay? And classically with quadratics, I want to set them equal to my favorite number, 0. So I would subtract 100 from both sides. That gives me 3t squared plus 5t minus 100 is equal to 0. And then I would factor it. Okay? This is not going to be a nice one. Don't worry, a quadratic formula if you can't factor it, but this one really does factor. It is 3t times t. That's the only way 3t squared can factor. But 100, you got options here. 100, you got 101. You got what? 2 times 50. You got 4 times 25. You got 5 times 20. You with me? And the other 3t squared is actually just 3t and 1t. And you want to figure out, because it's a minus, I'm going to multiply one of these numbers by one of these numbers and the other one by the other one, and I'm going to take the difference to get 5. Well, 3 times 5 is 15. 1 times 20 is 20. And what's the difference between 15 and 20? 5. So this maps to this here. I want to multiply the 3 times the 5, and I want to multiply the t times the 20. Now I want to do my signs here. This is equal to 0. Let's see here. Because I want the bigger number to be plus, let's see here, 20 times t, that'll be the bigger number, that's plus, and then the 3t times the 5 is the 15, I want that to be minus. So this is how it factors. If you need to, quadratic formula. By this time you got a calculator. You can graph this thing and see where it crosses the x-axis. I'll show you that trick in a second. But now, here's the actual algebra. Set both factors equal to 0 and solve. I end up getting, to subtract 20, I get 3t equals negative 20, divide by 3 on both sides, and I get t equals negative 20 thirds. Okay? Here I'm going to add 5 to both sides, and I get t equals 5. Does that make sense? What did they say about t in this particular problem? I wrote it down. T's got to be what? It's time, and they went out of their way to say it's got to be a positive time. So this answer is absolutely meaningless because of time's got to be greater than or equal to 0. So there's only one time. What is that time? 5. Does that make sense? And now you want to find the velocity at 5. So the velocity at 5 would be 6 times 5 plus 5. 6 times 5 is 30, plus 5 is 35, and that would be, because it's velocity, feet per second. The answer is D. And just to show you, if this factoring bothered you and you're kind of concerned because it's not, leading coefficient of 1, you could have done this. Go to y equals, type in the equation. 3x squared plus 5x minus 100. And I'm just going to do a zoom 6, negative 10 by 10, negative 10 by 10 screen. It's a parabola. It goes down and comes back up. But all I care about is my times. And here are my 2 times. This one right here is 5. It clearly crosses there. This one you can do second calculate. Actually, it's called a 0. And I can take it over here to the left, my little cursor. There it is. I hit enter. Look between there, and there's my cursor right there. In between there, and I guess close is right about there. And it'll tell me negative 6.666666, which is the same thing as that negative 20/3. But the fact is this is negative, so I don't need that point at all. The other one's pretty obvious, it's 5. Just what you can do with your calculator, because now you've got calculator active for section 5. All right? Don't be surprised by this. Guaranteed you're going to get some implicit differentiation problems. And here's one right here. 2x times y cubed plus 4x minus 2y equals 10. Your mission, find dy over dx at the point 2, 1. And so there's a trick to help you guys out when you've got to evaluate an implicit differentiation at a point. Now, when we did implicit differentiation, we would take derivative of it, and then you would solve for that dy over dx, get it by itself, and then get your answer and then plug in the numbers. But you could make some careless errors. So let me show you a little trick here. All right, it's still implicit. So here's your equation. 2x times y cubed plus 4x minus 20y equals 10. You want to take the equation and take the derivative with respect to x. Because you can't solve for y on this thing, so you just jump in with both feet. If you look at this dude right here, it is 2x times y cubed. To take derivative of 2x times y cubed, you got to do a product rule. So product rule, derivative first. What's derivative of 2x? 2. And it's an x with respect to x, just regular derivative 2. Remember, with y's, every time you take a derivative of y, you got to tack on that dy over dx from the implicit part. So, derivative of product rule, derivative of 2x is 2 times the second y cubed plus the first 2x times derivative of the second. Derivative of y cubed is 3y squared, but it's a y variable, so you have to tack on that times dy over dx. Plus, the derivative of 4x with respect to x is just 4. That's a regular x variable, so you just take derivative normally. Minus the derivative of 20y is going to be 20, but it's a y, so you got to tack on that dy over dx is equal to 2. Oh, my fault there. Sorry, 2. Miscopied it when I wasn't looking. 2y. 2y equals, what is the derivative of 10? 0. Does that make sense? Now, if they asked you for the formula for dy over dx, you would keep these two terms on one side. You would subtract 4 and subtract the 2y cubed, factor out the dy over dx, and then divide. You with me? But if you want to save some time and less chance of careless error, at this point, since you want to find it at a point, I can go ahead, after you take derivative, and go ahead and plug in x is 2 and y is 1. It saves a little time and less chance for careless error. So here it is. You get 2 times y is 1 cubed plus 2 times x is 2, 3 times y is 1 squared times the dy over dx plus 4 minus 2 dy over dx equals 0. Let's clean up the arithmetic here. And I don't need to calculate for this either. 1 cubed is 1 times 2 is 2. 2 times 2 is 4 times 3 is 12. Times 1 squared is 1 times 12. That would be plus 12 dy over dx plus 4 minus 2 dy over dx equals 0. Combine like terms here. 2 plus 4, that's pretty much 6. 12 dy over dx minus 2 dy over dx will be plus 10 dy over dx equals 0. And it becomes real easy to solve for dy over dx. I would subtract 6 from both sides. I end up getting 10 dy over dx equals negative 6. And then I would divide by 10. And so dy over dx is equal to negative 6/10 or negative, what, 3/5. But they went ahead and put it decimals. What is the decimal version of negative 6 divided by 10? Negative 0.6. And so the answer is C. Does that make sense? I mean, yeah, I have a calculator. I could have done it on that thing too, but the number's not too bad. Take a look at the next guy. Let f of x be equal to kx plus 2 over x for some positive constant k. This function has a critical number at x equals 2. Find the value of k and determine if x equals 2 gives you a maximum or a minimum, okay, or neither. All right, so the first thing is this. I got to figure out what k is going to be. Looks like it's either going to be 1 or a half, or I pretty much can't tell. All right, so here we go. To have a critical number, what does a critical number mean? This is a definition thing. So when they tell me a critical number at 2 means that f prime of 2 has to be equal to 0. That's the idea right there. So the first thing I'm going to do is I'm going to take my function, which is f of x is equal to kx plus 2 over x. And I'm going to take its derivative. But before I take its derivative, I'm going to clean them up. So f of x is equal to, well, kx is good, but I don't like variables in the denominator when you got constants in the numerator. So I'm going to bring it to the top, and that gives you 2x to the negative 1. Now, take my derivative. F prime of x is going to be equal to, what's the derivative of, here it is, k times x, where k is a constant. Just k. Derivative constant times x is the constant. Plus, what's the derivative of 2x to the negative 1? Classic power rule. Negative 1 times 2 is negative 2x, and subtract 1, negative 2. So when I clean that up, I get f prime of x is equal to k minus 2 over x squared. But now, here's the deal. I know that f prime of 2 must be equal to 0. That's what it's going to get me to solve for k. So f prime of 2 would be k minus 2 over 2 squared. And that will be equal to 0. This is an equation. K minus 2 squared is 4, and 2 over 4 is a half, equals 0. You with me? So add a half to both sides. K equals 1/2. You with me? So the answer is now 50-50 shot. The answer is either C or D. So now, here's the deal. I know what K is. Now, how do I know if this thing's going to be a maximum or a minimum? Now, we know 2 is my critical number. This is called the second derivative test. I'm going to take my second derivative. My second derivative is the derivative of the first derivative. This is special right here, so I'll put a little asterisk by it, just to remind you. Second derivative measures concavity. You with me? So, my second derivative, so here's my first derivative is right here. I'll circle it because I want to take derivative again. What is the derivative of k being a constant? What's the derivative of constant? 0. So I'm going to put 0, that's for your benefit. Minus, what is the derivative of minus 2x to the negative 2? Negative 2 times negative 2 is a plus 4, x to the subtract 1, negative 3. So I'm going to clean that up. That gives me f double prime of x is equal to 4 over x cubed. Now, where's my critical number at? My Cn, critical number is where? X equals 2. So I'm going to plug in 2. F double prime of 2 is 4 over 2 cubed. 4 over 8, which is a half. I don't care what the number is. What is the sign of a half? It's positive. This is positive, and this is the second derivative, which measures concavity. Second derivative positive means it's concave which way? It's concave up. So if I've got a critical point, and I know it's concave up, what kind of critical point do I have? It's at the bottom. It's got to be a minimum. So k equals a half, and it's going to be a minimum. Answer is, make sure you grab the right one. Answer is C. Does that make sense? Did I lose you guys anywhere? Well, the other thing I guess you could have done was this. See that equation right there? I mean, you could have cheated on the calculator, but this is the calculus you need to know here. K was a half, so it's x divided by 2. Excuse me, x times 2. K was a half, so that would be x divided by 2 plus 2 divided by x was your function. And if I go and zoom 6 that thing, here it is. Now, and we were focusing on 2, right there at 2. So if I zoom in, well, this is zoom in right there at 2. This is for your benefit. Over here at 2. Look at 2. What kind of point is right there at 2? Yeah, it's on the bottom. It's a minimum. You could have cheated and done that. But this is so much better when you actually use calculus. Does that make sense? Question? Yeah, absolutely. You could have done that too. Absolutely. But the problem is this, because look at your function, you got to make sure you omit 0 because it's a vertical asymptote there. So you got to skip over 0 as well as focus on 2. But, or like I said, since this is a calculator active section, you could just, once you get k is a half, basically graph the function, then you can just look at the darn point and see if it's on top or bottom. This is on the bottom, so it's a minimum. Take a look at this guy. Yep, you're going to see one of these guys. Here it is. We wish to use to solve x cubed plus 4x equals 7 using Newton's method. Use x equals 1 and find your x2 next approximation on this guy. All right, so here we go. Newton's method. You with me? This is what you need to know. For Newton's method, your function has to be equal to 0, number 1, and the formula for your iterations is xn plus 1 is equal to xn minus f of xn divided by f prime of xn. How you get your next iteration. You got to know this formula. So, here was the trick here. They gave you this equation. X cubed plus 4x equals 7. But to be able to do Newton's method, you got to set the function equal to 0. So the easiest way to do that would be subtract 7 from both sides. So that gives you x cubed plus 4x minus 7 equals 0, which tells me f of x is equal to x cubed plus 4x minus 7. I need the function, and I need its derivative. So f prime of x is going to be equal to 3x squared plus 4. Okay? Now, we're going to use Newton's method. This is my formula right here. So, they gave me x1. x1 was equal to 1. So your next iteration, x2, would be equal to x1 minus f of x1 over f prime of x1. Now I'm writing this down so you can try to see what I'm doing here. But x1 is equal to 1. So this would be 1 minus f of 1 divided by f prime of 1. So x2 would be equal to, what's f of 1? I don't need a calculator for that. So this will be 1 minus, 1 cubed is 1. I can do that. 4 times 1 is 4. 1 plus 4 is 5. And 5 minus 7 is what? Negative 2 divided by f prime of 1. 1 squared is 1 times 3 is 3 plus 4 is 7. A minus makes it a plus. So this is 1 plus 2/7. But then, I didn't need a calculator until now. Look at your answers. They're all in decimals. Fine. We got a calculator then. Fine. Let's go grab our handy dandy calculator and put it up here so you guys can see it. So I'm just going to type this in. 1 plus 2/7, right? And the answer is 1.285714286. They went to 2 decimal places. Rounding rules on 2 decimal places. What's my answer? 1.2 what? 9. That 5 rounds that 8 up to a 9. So there it is, 1.29. And be careful, because look at those answers. They got 1.28 and they got 1.29. 1.29 is the right answer. Rounding rules. Does that make sense? All right, let's take a look at this guy. Suppose that f prime of x is equal to 1 minus 4 over x cubed, and f of 1 equals 5. Find a formula for f of x, then evaluate f of 2. They gave you f prime, and they're asking about f of x. What do I have to do? Antiderivative. They didn't use the word general antiderivative. They didn't use the word integrate. They gave you the derivative and they asked about the function. You should know this is antiderivative. This is my formula. F of x is equal to the integral of f prime of x dx. So to get f of x, I'm going to have to integrate 1 minus 4 over x cubed dx. But remember John's fun rule of calculus, clean up first. I don't like variables in the denominator unless it's just an x. The integral of 1 over x is the natural log absolute value of x, special rule. But x to any power, you want to bring them to the top. So this is the same thing as the integral of 1 minus 4x to the negative 3 dx. So here we go. I'm going to integrate this guy. So f of x is equal to the integral of 1 with respect to x. Remember, antiderivative. The integral of 1 is x. Minus 4 is a constant. Integral of x to the negative 3. X to any power, you add 1 over add 1. Negative 3 plus 1 is negative 2. X to negative 2 over negative 2. And then what do you put? One big what? Plus c. Anytime you integrate, you've got to have a plus c for this stuff. So cleaning this guy up, I get f of x is equal to x. Negative 4 divided by negative 2 is a plus 2. X to the negative 2 makes it over x squared plus c. Now, they gave me an initial condition, and that is that f of 1 is equal to 5. What is the initial condition on a general antiderivative formula used for? To find what that actual c is. So, plug it in. F of 1 would be 1 plus 2 over 1 squared plus c, and that's supposed to be equal to 5. That's an equation. 2 over 1 squared. 1 squared is 1. 2 divided by 1 is 2. 2 plus 1 is 3. That gives me 3 plus c equals 5. I'm going to subtract 3 from both sides, and that gives me c equals 2. So there's my answer. Well, almost. F of x is equal to x plus 2 over x squared plus c, but c is 2. Does that make sense? One more hoop to jump through. What do they want me to do in this problem? Oh, yeah. Evaluate f of 2. One last thing. Plug in 2 and get your answer. So therefore, 3 dots in a triangular fashion means therefore mathematics. F of 2 is going to be 2 plus 2 over 2 squared plus 2. I can crunch a bunch of 2's here. The 2 plus 2 is 4 plus 2 squared is 4, but 2 divided by 4 is 1/2. So what is my answer? Well, they went decimals on it, so let's go for decimals. 4.5. Does that make sense? The answer is 4.5. Does that make sense? All right. So, I have finished up part number 2. Okay? And looking at our clock of supposed to be 3 hours, I'm pretty much have gone about an hour and a half into this thing. You with me? And now I have 5 questions on the free response. Let me describe to you guys about the free response on this thing. Okay? The free response is a time for you to, one, shine for us. Never, ever leave anything blank. You know something about a problem. Our goal as mathematicians, in terms of teaching calculus, and especially at the engineering calculus level, we're going to give you problems you've never seen before. And we want to see if you can actually do something rather with them. Okay? No, your knowledge is key to this particular material. That's the kind of problem we're going to give. So we're going to give you some problems you may have never seen before, but with your calculus knowledge, you should be able to figure it out. And you know something about something or other, write down what you know, and maybe you can put it together. A lot of the times they'll do these steps to try to get you through the problems and stuff, but if you get confused, do the problem the way you think it should be done, and then go back and put the parts into the answers and stuff like that. Show your work, be neat, be organized. We do grade this thing off partial credit. So if you didn't get it completely right, you could still get some major points out of the darn thing. So show your work, but if we can't read it, nothing. I got 2,000 some odd calculus students. And here's the deal. There's going to be 5 groups of us professors. Usually I'm going to have me and I'm going to have a grad student at my side. Okay? And I'm going to sit there and grade these things with my assistant, and we're going to grade it 2,000 times. And I got 2,000 papers to grade. I'm going to look at this thing, and if in 3 or 4 seconds I can't figure out what exactly you're doing, makes it easy for me. Next problem. Because I've got to do this thing in the mass production thing. So you want to be neat and you want to be organized. Because if you're neat and organized, I can follow along. And then I'll spend some more time on your paper and be cranking you some more points. That's the key to it. Hopefully you get the thing completely right and get full credit for it, but in case you don't, show your work. Neat and organization is key. All right, so here we go. They do like problems from web work. Here is a problem from web work. And so this one was hopefully not too bad. They gave you a table. We stole this one off of web work. They tell you, you got your x's, which is 1, 2, 4, and 8. You got f, and you got f prime of x. So here's what we want you to do. G of x is equal to x squared times f of x. We're basically testing your derivative knowledge. You're supposed to find g prime of 4. Before you can find g prime of 4, you've got to find g prime of x. This is a product. I'm going to use the product rule. Derivative of the first times the second plus the first times derivative of the second. Even with formulas. Derivative of the first, derivative of x squared is 2x times the second, f of x, plus the first, which is x squared, times derivative of the second. Derivative of f of x is f prime of x. So there's my official derivative of g form. And now I want to find g of prime of 4. So g prime of 4 would be equal to 2 times 4 times f of 4 plus 4 squared times f prime of 4. So g prime of 4 would be equal to 2 times 4 times f of 4. What's f of 4 equal to? I go to my chart. F of 4 is 5 plus 4 squared times f prime of 4. F prime of 4 is negative 1. So 2 times 4 is 8, and 8 times 5 is 40. 4 squared is 16 times negative 1 is minus 16. And 40 minus 16 is how much? 24. And for you people, just in case you wanted to know it, 40 minus 16. Don't make bonehead careless errors, all right? Double check your stuff. It's all right. But here's what I want to point out to you guys. This is the work we want to see. The actual formula. Plugging it in. Be methodical. Don't skip steps. Show us what you know. You with me? Look at the next one. Next one is h of x is equal to f of x divided by 2x plus 1. Well, and again, we want to find h prime, in this case of 2. H prime of 2 won't derivative. This is a quotient. So I'm going to use the quotient rule. Derivative the top times the bottom minus the top, trying to derivative the bottom all of the bottom squared. So h prime of x would be equal to quotient rule. Derivative the top. Derivative of f of x is f prime of x times the bottom, 2x plus 1 minus the top, f of x, times derivative of the bottom. Derivative of 2x plus 1 is 2, all over the bottom, 2x plus 1 squared. There's my derivative in all its glory. This is what we're looking for. We got to have the formula first. Now you got half credit on this thing already. So keep going. Now I want to find h prime of 2. That would be f prime of 2 times 2 times 2 plus 1 minus f of 2 times 2 over 2 times 2 plus 1 squared. Now f prime of 2, I come up here and look at my chart. F prime of 2 is how much? 3. So this would be 3. I will crunch this out. 2 times 2 is 4 plus 1 is 5. Minus f of 2. Back to the chart. F of 2 is 4 times 2 all over 2 times 2 is 4 plus 1 is 5 squared. So 3 times 5 is 15 minus 8 over 25. And 15 minus 8 is how much? 7 over 25. And there's my answer. But you see how methodical I am and neatness counts? This is what we're looking for. Don't be sloppy with this stuff. Not with this format. We want to see all the work. This is the work we expect to see on this one. Take a look at the next one. K of x is equal to 3x plus f of x squared. So f's on the outside, x squared's on the inside. That's a chain rule aspect here. So we want to find k prime of 2. So k prime of x will be equal to, now, so derivative. What's derivative of 3x? 3. No problems there. Plus, here's the trick that most people messed up on this one. What is the derivative of f of x squared? You've got to look at that as outside, inside. That's chain rule. Derivative of the outside, inside stays the same, time derivative of the inside. So derivative of the outside, derivative of f is f prime. The inside, x squared stays the same, but then you got to do time derivative of the inside, which is 2x. That's what we're looking for. That's your derivative. Now we want to find k prime of 2. So k prime of 2 would be equal to 3 plus f prime of 2 squared times 2 times 2. So cleaning that up, that'll be 3 plus f prime of 4 times 4. 3 plus, what is f prime of 4? Back to the chart. There's 4. F prime of 4 is negative 1. So that'll be negative 1 times 4. So that's 3 minus 4. So the answer is negative 1. Does that make sense? And you see how neat and organized I am, just in case you made some bonehead mistake, like, 4 times 5 is 45 or something like that, and then working that. If we find that, but the math is correct, except your arithmetic is bad, we can at least get you some partial credit on the thing. Does that make sense? Show your work. I'll warn my students about a problem like this. It says this: a function f satisfies the conditions below. The domain of f is all x except x equals 1. X equals 1 is a vertical asymptote, and then they give you some information. The limit as x approaches infinity of f of x equals 1. F of negative 2 equals 0. F of negative 1 is equal to 1. F of 0 equals 2. F prime of x is greater than 0 on the interval between negative 2 and 0. F prime of x is less than 0 on the interval between negative infinity and negative 2, union 0 to 1, union 1 to infinity. F double prime of x is greater than 0 on negative infinity to negative 1, union 1 to infinity. And F double prime of x is less than 0 on the interval between negative 1 and 1. Your missions. List any horizontal asymptotes for f. B. List the x-coordinates of any relative extremum of f. If none, write none. C. Sketch the graph. All right. Honestly, with a problem like this, graph it first. It makes it so much easier to go back and answer the weird questions they have. So let's take a look at this information and let's graph it. All right? Now, they gave me plenty of room to graph the darn thing down here, but for me, well, I guess I could graph it down here. I'll just have to do this. You guys can see me graphing this thing. All right? Now, when I graph, the first things I'm going to graph are information I know. I got a vertical asymptote at negative 1. I also have these points. F of negative 2 is 0, F of negative 1 is 1, and F of 0 equals 2. So these are points that I have right there. So I want to make sure I nail those things out. So down here, I'm going to put my coordinate axis. Okay? And it didn't make the points too bad in terms of my y-coordinates. So over here, f of negative 2 is 0. So here is negative 1. Here is negative 2. F of negative 2 is 0. So I've got a dot right there. F of negative 1 is 1. So up here, I'm going to put the y-coordinate right here at 1. F of negative 1 is 1. And I'm going to put a dot. F of 0 is 2. So here's 0, and here's my mark. There's 2. Okay? Also, they gave me x equals 1 is a vertical asymptote. So over here at 1, vertical asymptote, here's my vertical dotted line right here. This is the vertical asymptote at x equals 1. All I did was plot my points. You with me? Now, here it comes. I got this information right here. Tell me what that means. The limit as x approaches infinity of f of x equals 1. That means, here's my x-axis right here. When I go towards infinity, you're going to horizontal line, you get 1. So you get a horizontal line right there at 1. Does that make sense? As x approaches infinity, you're leveling off at 1. Y-coordinate is 1. That's what I'm getting that information right there from the limit. Does that make sense? Now I'm going to put the rest of the stuff in here. What does, let me put it up here so I blow it up, so I'm jumping back and forth here. What does f prime of x being greater than 0 mean? Your first derivative is positive. What does it mean? Positive slope. I'm increasing. So this will be increasing. So I'm going to draw little lines of increasing between negative 2 and 0. These are x coordinates. So between negative 2 and 0, I know, and this is, watch what I do, I know I got to be increasing. And I'm drawing it right lightly in here. I'm going to be going up. I don't know about concavity, so I'm making it light. I'll put the units in later. What does it mean for f prime of x to be less than 0? I am what? Decreasing. From negative infinity to negative 2, I'm going down. From negative infinity up to negative 2, so negative infinity is this way, up to negative 2, I'm going to be going down. So I got this idea of going down right there. Okay? I'm also going to be going down between 0 and 1. So between 0, here's 0, and I got to go to that point right there to 1. But 1 is a vertical asymptote. Horizontal asymptotes you can cross all day long, but vertical asymptotes you can never cross. It's a point that doesn't exist. So if I'm going down between 0 and 1, between 0 and 1, there you got to see it, 0 and 1, and I can't cross, 1 is a vertical asymptote. If I've got to go down, I've got to go down, right? And I can't cross this line, so it's going to have to continue to go down. Does that make sense? And then I'm going down between 1 and infinity. Now remember, I've got to come to this line at infinity. So a vertical asymptote you can't cross. So I either got to start at the bottom or I got to start at the top. But since I'm going down, I can't start at the bottom and go down. I'll never see that picture. To be able to go down and hit this guy right here, I've got to go down. Does that make sense? Now I'm going to put the concavity in this thing. The second derivative is greater than 0. What does that mean? I'm concave which way? I'm concave up. I'm concave up between negative infinity to negative 1. Negative infinity up to negative 1. Negative infinity to negative 1. So you see this little V? It's actually going to be concave up. Now I'm making it dark, so I'm putting the units into this graph. I'm going to be concave up also between 1 and infinity. Here's 1 and here's infinity. So this thing's going to be concave up, but I got to hit that line right there. So this would be, making it bold, concave up. But remember, you can't cross a vertical asymptote, so it's going to go straight up on that. Does that make sense? And last but not least, f double prime of x is going to be less than 0. That means it's concave down between negative 1 and 1. Between negative 1 and 1, between these 2 points, it's got to be concave down. So change concave down goes here and concave down. But remember, vertical asymptote I can't cross, so I got to continue to go down. Does that make sense? And there is my graph. So there's the big point total right here. Now, let's go back and answer questions. Do you have any horizontal asymptotes? Horizontal asymptotes are lines that, as you go to infinity or negative infinity, you approach. What's going on here? You have a horizontal asymptote where? At y equals, horizontal asymptotes are y equals, vertical asymptotes are x equals. Where's it at? 1. That's your horizontal asymptote right there. List any x coordinates that are relative extrema. You got any relative extrema as fancy words for max mins? You got any max min points on this thing? What you got? I got a maximum and I got a minimum. They're relative. Right here at negative 2. X is equal to negative 2. And what kind of point is that? This one is a relative which one? Minimum. Relative min is good enough. We'll take that. And I got one other point. What point is that? These are all about x coordinates. So my focus is on the x coordinate. X is equal to 0. And x equals 0. And that's going to be a relative at the top maximum. And I answered my questions. Does that make sense? I'll lose you guys anywhere. Question?
Do you have a horizontal asymptote at y equals 1?
Yeah.
Does it matter that on
No, exactly. What did I say about horizontal asymptotes? Horizontal asymptotes, you can cross them all day long. And it's only on one side, it's not on the other. This thing will continue to go up there. Don't care. You can, look at it, I'm crossing that thing all day long. It only happens at infinity. It's the vertical asymptotes that you can't cross. Yeah? What's that now? Oh, relative maxima. Oh, your maxima, it would be this one right here. I should actually read the questions right. It's a maximum at this one, but relative extrema is usually what they ask for. And you're right. If they ask for extrema, I gave them more information than they wanted. More information is better than less information. Okay? So I'm trying to be teachable moment, but you're right. This is the relative maxima. This is your max. The extrema is any kind of max min point. So I'm just trying to get you used to the terminology, but you're right. All right, take a look at the next guy. Now, here we go. Use the formula f prime of a is equal to, the limit as h approaches 0 of f of a plus h minus f of a over h, to find f prime of 3 for f of x equals 2x squared plus 4x plus 1. No credit will be given if you cheat. Okay. I'm sorry, if you do not use the formula above. Okay? Let me show you what a lot of people did. I'll explain that later. All right, so this is one from chapter 2.1, 2.2, 2.28 in particular. We want you to actually use the definition of derivative. So here's the deal. F of x is equal to 2x squared plus 4x plus 1, and we're supposed to find f prime of 3. Okay, which pretty much tells me that a is equal to 3. Does that make sense? Since we're looking for f prime of 3. So this would be equal to the limit as h approaches 0 of f of a is 3. So that will be 3 plus h minus f of 3 all over h. Some semesters we use f of a. Some semesters we use f of x and make you use the x thing and actually find the derivative guy. So just be familiar with that. Just replace a with x and you get the famous definition derivative formula. So this is what we want to do. But this one, we want to show you the work. I didn't say anything about evaluate. They actually want you to show the work on this one, especially where there are no credit will be given aspect here. So here we go. What is f of 3 plus h? I don't care what's inside the parentheses. You replace the x with it. So that would be 2 times 3 plus h squared plus 4 times 3 plus h plus 1. What is f of 3, the other part? That would be 2 times 3 squared plus 4 times 3 plus 1. Okay? Now, for this guy, with the numbers, I can actually crunch it out. So here we go. So f of 3 would be equal to 3 squared, which is 9, times 2 is 18. 3 times 4 is 12, plus 1. 18 plus 12 is what? 30, plus 1 is 31. So, f prime of 3 is going to be equal to the limit as h approaches 0 of f of 3 plus h. That's this function right here. That'll be 2 times 3 plus h squared plus 4 times 3 plus h plus 1 minus f of 3, which is a number, which is minus 31 all over h. I just substituted in. Now, clean it up. Cleaning this up, you get f prime of 3 is equal to the limit, and you keep writing that word limit. Neatness and organization counts. Now, this will be 2 times, and this is for your benefit. What does 3 plus h quantity squared really mean? It means it's 3 plus h times 3 plus h. If I'm going to clean up this guy, I would distribute the 4. That would be plus 3 times 4 is 12. And plus 3 times 8, 4 times h is plus 4h, plus 1 minus 31 all over h. All I did was distribute a little 4 there. Now, for me to clean this up, because you got a binomial times a binomial, you're going to FOIL it out. So I'm trying not to skip any steps at all in showing you my work. So f prime of 3 would be equal to the limit as h approaches 0 of 2 times, here we go, FOILing it out. 3 times 3 is 9. 3 times h is plus 3h. h times 3 is another plus 3h. And h times h is plus h squared, plus 12, plus 4h, plus 1, minus 31, all over h. And I can clean this up just to save some time. What is 3h plus 3h? You can do that kind of math in your head. 6h, combine like terms. And I'm going to distribute the 2 now. So f prime of 3 would be equal to the limit as h approaches 0 of 2 times 9 is 18. 2 times 6h is plus 12h. 2 times h squared is plus 2h squared, plus 12, plus 4h, plus 1, minus 31 all over h. I'm not skipping any steps. This is the deal we wanted you to show us the algebra. So this will be the limit as h approaches 0 of. Here we go. Combine like terms. What is 18 plus 12? 30. Plus 1. Minus 31. All the constants cancel. Keep going. 12h plus 4h is how much? 16h plus 2h squared. Combining like terms here. All over h. And it's a classic limit. If I plug in h right now as 0, I'm going to get 0 over 0. But this, I'm not going to use L'Hopital's rule on this one. I want to show algebra. What do you got in common in that numerator? H. So let's factor the h out. So this is equal to the limit as h approaches 0. Factoring the h out, you're left with a 16 plus 2h all over h. Factoring h out of your numerator. And the h's cancel. So f prime of 3 would be equal to the limit as h approaches 0 of 16 plus 2h. And then once you cancel that h off the bottom on that classic definition of derivative mess, I'm going to do the limit. First rule limit, plug in the number. Plug in h is 0 now. So this will be equal to 16, and you don't write limit anymore, plus 2 times 0, that's 16. Therefore, f prime of 3 is equal to 16. That is my answer. Does that make sense? And remember, there's a question. Use the formula to find f prime of 3. That's what I did. But you and I both know what a bunch of brainheads did, okay, on this particular problem. Question is, here's f of x, which was 2x squared plus 4x plus 1. They took derivative of it. Don't hurt yourselves. What's derivative of 2x squared is 4x, plus derivative of 4x is 4. And then they plugged in 3. That'll be 4 times 3 plus 4. 4 times 3 is 12, plus 4 is 16. And how many points you think they got for doing that kind of crap? Oh, we took extra points off of that. So, because it said you show your work and do not, you have to use the formula of the limit stuff here. But we had quite a few people, they didn't want to do it this way. They want to do it this way. I'm glad you learned something. Don't get me wrong, but follow darn directions, man. Use the definition derivative on this problem. Does that make sense? Questions? Oh, yeah. You know there's going to be an optimization problem, and there's going to be a related rate problem. Let's take a look at this guy. A rocket is fired straight up from the ground and reaches a height of 5t squared feet after t seconds. An observer 315 feet away watches the rocket rise. If the observer's eyes are 5 feet above ground level, how fast is the angle in the diagram, angle theta, in the diagram below changing, aka find d theta over dt in radians per second when the angle theta is pi-4 radians. All right, big related rate problem. But the first thing you're going to have to do is you need to plug the formulas in on this thing. So I'm going to kind of redraw my triangle because some stuff's going on here. So here's my triangle right here. And notice it's a right triangle. So this is a very important problem, so make sure you can do this. Here's your right triangle right here. Here is your theta, and this is your constant, 315. Here's the problem. The rocket started on the ground and started to shoot up. And they gave you the equation for the height of the rocket, which is 5t squared. But the angle is not on the ground, it's up here. It's in the corner. So what I need to do is have a formula for this little section right here, because that's what's in the triangle. Does that make sense? This whole thing is not in the triangle. So what is the formula for this little guy here? It's going to be 5t squared, but then you need to take away the bottom, minus 5. Does that make sense? Because you're not calculating, you're looking at it from eye level and looking at the angle go up. So that distance from the eye level down to the ground needs to be taken away from the formula for the rocket. Does that make sense? That was the trick right there. And that becomes the height based upon your eye level. So here is our right triangle type thing here. Now, we need, because it's a related rate problem, and the question is, we want to find d theta over dt when theta is equal to pi force. That's the whole goal right there. But I got to come up with an equation. Now, you've got three things going on here. Your focus has got to be on that angle, because that's the whole trick right there. We've got to find d theta over dt. Well, I've got this opposite side, and I have the adjacent side to a right triangle. So you need to know this. What deals with opposites and adjacents? Tangent. So we know that the tangent of any angle is equal to the opposite side divided by the adjacent side. So that's going to lead me to my formula for this triangle, which is the tangent of theta is equal to the opposite, which is 5t squared minus 5, divided by 315. Does that make sense? Now, I'm going to clean this guy up a little bit here, okay? So, let's see here. Now, I'm going to take the derivative of this guy, okay? Let's just talk about logic here for a second. I want to take the derivative of this guy with respect to t. And so over here, the derivative of tangent is going to be some secant squared of theta, but then you got to do time derivative inside because you take derivative with respect to t, times this d theta over dt is equal to basically the derivative of this guy. But when you take derivative of this guy, you got to plug in theta is going to be pi force, but I need to know what the time is as well. So before I actually take the derivative of this guy, I know theta is equal to pi force, but to be able to solve this thing, I need to figure out what the t is. So I'm going to come over here and take this and go ahead and plug in theta's pi force. Here it is. It'll be the tangent of pi force is equal to 5t squared minus 5 over 315. Now this is something you should know. What is the tangent of pi force? Pi force also known as 45 degrees. What's the tangent? Well, it's the same thing as sine over cosine. Sine of pi force square root 2 over 2. Cosine's pi force square root 2 over 2. So square root 2 over 2 divided by square root 2 over 2 is 1. Here guys, 1. But for those people that all that unit circle stuff just kind of went over their head, you do have a calculator. Just make sure your mode is in radians and type in tangent of pi force, and do not be alarmed when the answer is 1. Okay, you're supposed to know that. There it is, 1. Now, I'm going to solve for t here, 5t squared minus 5 over 315. And we're going to solve for t. So I'm going to multiply by 315 on both sides. Again, try not to skip a step with you guys. So that gives me 315 is equal to 5t squared minus 5, because that would have canceled here. And then I'm going to add 5 to both sides. That gives me 320 is equal to 5t squared. I'm going to divide by 5, and I'll put that on the old calculator here. And 320 divided by 5 is a whopping 64, which makes me feel better about life because, you know, with these problems, I like to have nice numbers. And 64 is a great number to be equal to t squared. So what do I got to do to get rid of that square? Square root. Now, t represents time, and we're talking about shooting rockets, so officially I can do plus or minus, but I really don't care about the minus t because we're talking about time of a word problem. So I'm going to take the positive square root of both sides, and I get t is equal to 8. So t equals 8 seconds is when the rocket actually reaches that pi force 45-degree angle. Does that make me? So now I needed that. So now that I got t, I got pi force, and I got t equals 8. Now, to be able to get this particular problem right here, I need to take its derivative. This is that related rate thing. Now, I'm going to clean this guy up a little bit because I don't like fractions. And because this is a constant, this is just design, I'm showing you guys a trick to help you guys out. I'm going to go ahead and take my equation and multiply by 315 on both sides. All it does is clean up my equation with less fractions. So when doing this, this is going to give me 315 times the tangent of theta is equal to 5t squared minus 5. And here we go. I am going to take this equation, a little bit cleaned up now, and take the derivative with respect to t. You with me? And here we go. 315, here's your real calculus right here. It's what we're looking for. 315 is a constant. Leave it alone. What is the derivative of the tangent of theta with respect to t? Well, it's chain rule. What's the derivative of tangent? Secant squared. The angle theta stays the same, but then times the derivative of the inside. What's the derivative of theta with respect to t? You got to tack on this d theta over dt, which is what I'm going to solve for. Does that make sense? Every time you're taking derivative with respect to t, because everything's based on time on this thing, but when you take derivative of theta, you get that d theta over dt, which is the dude you're trying to solve for. Then that would be equal to, now the other part is t. What is the derivative of 5t squared minus 5? Well, derivative of 5t squared is what? 10t, and derivative of minus 5 is 0. So now here we go. Here's my equation. What we want to find, remember the question here, we're going to find d theta over dt equals what when theta is pi force, and I actually know what t is. T was equal to what? 8 seconds. I needed the t to be able to plug into this thing. So now I'm at the goal line. Let's go solve this thing. So I end up getting this 315 times the secant squared of theta times d theta over dt is equal to 10t, plugging in my numbers. That would be 315 times the secant squared of pi force times d theta over dt is equal to 10 times 8. Let me blow this up for you guys in the back so you can see this. Now here we go. I want to clean this guy up. Now most folks don't know secant, so we threw a bunch of trig at you on this one, but you're expected to know it to be in this class because all your high school stuff. What is the definition of secant? 1 over who? Cosine. Secant is 1 over cosine. Things you're supposed to know from high school. So when I say secant squared of pi force, that's the same thing as 315 over the cosine of pi force, and that's still being squared, times d theta over dt equals 10 times 8 is 80. Now, what was the cosine of pi force? Square root of 2 over 2. Now you can throw calculator. We'll accept a calculator answer here, but I'm just trying to show you what you're supposed to know. 315 over the cosine of pi force is the square root of 2 over 2, and it'll be squared times d theta over dt equals 80. Now I'm just going to put that on the calculator just to show you, and you could have put the whole thing in the calculator if you wanted to. But here it is, and I'll show you both ways here. So this is 315 divided by the square root of 2 over arrow divided by 2 squared. Now the square root of 2 over 2 squared is 1/2. Square root of 2 squared is 2. Square root of 2 squared is 4. 2 fourths is 1/2. When you divide by half, you invert multiply. That'll be 2 times 315, which makes it what, 630? Yes, it does. So that would be 630 d theta over dt equals 80. geez, Dr. Taylor, it's been so long since I had trig, I don't know what to do. Well, then do this, dude. Take 315 and divide by parentheses cosine of pi divided by 4, close parentheses, squared, and you end up getting the same answer. But I did have to show you the idea that secant is 1 over cosine, because where's your secant button on your calculator? Exactly. So you need to know about some cosine stuff. Does that make sense? All right. Oh, yeah. Solve for d theta over dt. Win the game. I'm going to divide by 630 on both sides. You with me? And I end up getting d theta over dt is equal to 80 divided by 630, which is, okay, and we would have accepted this answer, 0.126984127, and that would be, it's what we like, the Leibniz notation. Radian, theta is in radians, that would be radians, rads per second. But for you guys that just love fractions, knock yourself out, I would also accept 8 over 63 radians per second. And that is the answer. Does that make sense? Did I lose you guys anywhere? Okay. Classic right triangle trig problem. But the twist on this one was, the fact is that I had to sit there, and they gave me theta, but I had to go plug theta in this thing to figure out the time that I needed, the 8 seconds. So when I took its derivative, I plug in for theta pi force, and then I would have to plug in for the time, the 8 seconds that I calculated. So there was a little extra. And have you done a problem like this before? No, and that's the point. They're going to give you one of these guys that if you know calculus and you know math, you can figure it out. This is what we expect you guys to do in the final exam. Does that make sense? All right. One more. Find the coordinates x, y of the point on the curve y equals 2 times the square root of x that is closest to the point 2, 8. Now, in my class, I beat to death this problem. I did it in class. I talked about one semester that the students, we put a problem like this on the exam. It wasn't this exam, it was years before. We put a problem like this. It was embarrassing, the word closest. We didn't give you any formulas or anything like that. We just said, find it closest. And our students couldn't relate. Closest means minimize distance. This is an optimization problem. So in my class, we put one in the notes, so everybody should have done that. I put one on the test. I mean, I did a lot of these kind of problems. Well, this semester, they brought back this sucker again. So let's see if we can do it here. But they gave you a little bit of a twist on this one. Now, let me describe this one to you. It is this. So we want to find the coordinates x, y on the curve. Y equals 2 times the square root of x that's closest to the point 2, 8. Now, I'm a big fan of drawing pictures because I want to visualize this stuff. So here it is right here. So if I plot points, here's 0. The square root of 0 is 0 times 2 is 0. Here's 1. The square root of 1 is 1 times 2 is 2. 1, 2. So it'd be right here. And so 1, 2, 3, 4, 5, 6, 7, 8. Not drawn to scale here, but there it is. There's my y-axis. So, and here's the point 2. So here's the point 2, 8. This is my point right here. 2, 8. Now this is a curve. And if I do the next point, the next good one would be 4. The square root of 4 is 2. Times 2 is 4. 1, 2, 3, 4. So 4, 4 would be right about here. And it's a square root problem, so it looks like this. So we want to find the point on this curve right here, which is quote-unquote closest to this point. Again, this thing's not completely drawn to scale, but it gives me an idea of where I can guesstimate where this point's going to be at. All right. So here's the thing. Closest means we want to minimize the distance. Now this particular semester, they were nice to you guys and actually gave you the distance formula. Distance is equal to the square root of change in y, y2 minus y1 squared, plus change in x, x2 minus x1 squared. I expect my students to know this formula. It's the distance formula, especially since we did like 3 problems in class there. So here it is. So there's going to be this point on this curve, and I'm going to say it's right about here somewhere. I'm not real sure, but it's an arbitrary point, xy. And this is the other point, because we're talking about the distance between these 2 points here. So, these are my 2 points. So the distance would be equal to the square root of the y-coordinate minus the other y-coordinate, which is 8 squared, plus the change in x's. The x-coordinate minus the other x-coordinate of the point, which is 2 squared. You're talking about the distance between the arbitrary point on the curve and the point 2, 8. So I plugged in for x2, y2, xy, and plugged in for x1, y1, 2, 8. So there's my equation. Problem is, this is the dude I want to take derivative of, set it equals 0, and solve. Too many variables. Okay? So the constraint, so this is the objective equation as written out. So the constraint is that I've got to be on the line. And that line is y has got to be equal to 2 square root of x. So I get to replace y, plug it right in there, and I get d to be equal to the square root of, replace y with 2 square root of x minus 8 squared plus x minus 2 squared. So this is the dude, and now I got it in terms of one variable, that I want to take derivative of, set it equals 0, and solve. They gave you a hint. The hint was right here. To maximize d is the same as to maximize d squared. To maximize d is the same thing as maximizing d squared. Minimize, excuse me about that. All right. To minimize d is the same as to minimize, there it is, minimize d squared. So to minimize d is the same thing as minimize d squared. That's what they stated right here. And the reason why they gave you that is to make this thing a little bit easier to take derivative of. So all we're going to focus on now is d squared. D squared would be basically d squared, which is the square root of the 2 times the square root of x minus 8 squared plus x minus 2 squared squared. And what happens when you square the square root? They'll cancel, and you're left with just this. 2 square root of x minus 8 squared plus x minus 2 squared. There's my equation. Now, I have a question for you. Now, I could take derivative of this dude, set equals 0, and solve. But take derivative of the first term, I can use the chain rule. Take the plus derivative of the second dude, I got to use the chain rule. I can do that. But since I got to set it equal to 0 and solve, I kind of want to clean this guy up before I take derivative, right? So to clean this guy up first, d squared would be equal to 2 square root of x minus 8 times 2 square root of x minus 8 plus x minus 2 times x minus 2. And I'm going to FOIL both these two guys out. I'm going to, quote, clean up my algebra here. Does that make sense? That would help you out because it's all about the algebra. I got to take derivative of it, and I can take derivative of multiple things, but then I want to set it equal to 0 and solve. So clean up the problem first before you take derivative of it. So here we go. Now I wrote it out like this because I saw too many students on this problem. They just distribute the two to make it easier on themselves. That's a violation of 45 rules of math, dude. You can't You can't distribute a power when you don't have strict multiplication division. That's a big old minus in here. So you have to actually FOIL it out. So here we go. D squared is equal to, here we go, help me out. What's 2 square root of x times 2 square root of x? Well, what's 2 times 2? 4. What's square root of x times square root of x? X. All right, let's keep going. What is 2 square root of x times a minus 8? That would be a minus 16 square root of x. Enter. Minus 8 times 2 square root of 8. Multiply the numbers. Minus 8 times 2 is another negative 16 square root of x. And then last, what is a negative 8 times a negative 8? Plus 64. And then there'll be plus. Now I'm going to FOIL out these guys. Don't worry, I'm going to combine like terms later. So x times x is x squared. X times 2, minus 2 that is a minus 2x. Minus 2 times x is another minus 2x. And minus 2 times a minus 2 is a plus 4. Does that make sense? All right. Let's combine like terms. So d squared is equal to, what do we got here? I got an x squared. I like decreasing order. So there's x squared. And usually I put a line through them. Let them remind me I've already used them. And now what else do I got? I've got an x, 4x minus 2x minus 2x, what? That completely cancels, so there actually is no x. I got a square root of x. I got minus 16 squared of x minus 16 squared of x. That's a minus 32 squared of x. And then I got a 64 plus 4 is how much? Plus 68. So I've cleaned up and combined some like term stuff here. Questions? Now, remember, and here's where I've seen a lot of my students fumble the ball and they're not even halfway down the field yet. This is calculus. So if you got a optimization problem or a related rate problem, what should you do to your problem? Take the derivative. Don't just try to set equals 0 and solve and forget the calculus aspect of this class. You're not happy unless you take a derivative of somebody. Okay? So now take the derivative of it. D squared prime. Derivative of x squared is 2x. Now, I don't do square roots. What's a square root also known as? X to the 1/2. I'm going to take derivative of it. Bring down the half. Half of 32 is 16. That'll be minus 16x to subtract 1. That'll be negative 1/2. And then the derivative of 68 is, this is for your benefit, 0. Okay? So, cleaning it up, d squared prime is actually, this would be 2x minus 16 divided by, negative exponent goes on the bottom, half a power is a square root, set it equal to 0 and solve. I'm going to move this term to the other side. I get 2x is equal to 16 divided by the square root of x. I'm going to multiply by the square root of x on both sides. Now, here we go. This would be 2x times the square root of x is equal to 16. Now, I'm going to go back and now do back powers. What's a square root also known as? Half a power. So this is 2x times x to the half. And when you multiply, because I'm trying to combine my variables here, when you multiply, you add exponents. What do I get? 2x times x to the 1/2 is x to the 1.5, which is what? 3/2 is equal to 16. And now I'm going to divide by 2 and move him over here, showing my work here. X to the 3/2 is equal to 16 divided by 2 is 8. And it made you work your algebra skills. What gets rid of a 3/2 power? Raising it to the 2/3 power. So I'm going to raise it to the 2/3 power. What I do to one side, I do the other, because power to power multiply. 3/2 times 2/3 is 1. 8, so x to the first, or x is equal to 8 to the 2/3 power. But again, working your exponents. When you got a fractional exponent, the denominator is your radical, the numerator is your power. So this is the same thing as the cube root of 8 squared. It was a nice answer. What's the cube root of 8? What times what is 8? 2. Yeah, don't hurt yourself. 2 squared. So x is equal to 2 squared. X is equal to 4. Does that make sense? But wait. Don't forget. 5 steps to doing word problems. What's always the 5th step? Go back and answer the question. What was the question of this problem? Find the coordinates. All right, I got x equals 4. So the answer the question here. I got x is equal to 4, and to get the y coordinate, you've got to go to the constraint. You've got to be on this line, y equals 2 squared of x. So y is equal to 2 squared of x. I'm going to plug in x as 4. So y equals 2 square root of 4. Square root of 4 is 2 times 2 is 4. So the point on the line is the point 4, 4, and that was the actual answer. Does that make sense? Did I lose you guys anywhere? Now, a couple of things before I let you guys go. First thing is this. I did this entire exam in 2 hours and 25 minutes. And I gave you explanation, detailed explanation of every problem. Does that make sense? On average, most students are done in about 2 to 2.5 hours like I did. Mine went a little bit longer because I was trying to explain what I was doing on this stuff. Now, question for you guys. How well would you have done on this exam? Well, that's good to know. At least a 70. Well, shoot high there, Barty. All right, so the class average on this particular exam was a 67.5. You know why? Word problems. All right, which ones you think killed you? Yeah, I had a triangle on it. People just left it blank. Okay, I ain't going to look at a triangle. You know something about every problem, you can do it. Okay? Don't get me wrong, we had lots of folks do incredibly well on this exam, but there were some pitfalls that made some people make some careless errors. And this was one of the problems. This one right here, actually, believe it or not, actually did knock some people down because of the interesting derivative and those exponential fractional power stuff there, messing people up. This one just completely devastated them. Most folks got on the free response part, they cheated on this one. You can see they lost points on that one just due to can't read the directions on actually use the definition of derivative stuff there. This one messed some people up because they got confused on that horizontal line test. Most folks nailed this one. Okay? So it was the free response part that actually messed people up on this one. So you can expect at least one of the problems on there to be something you haven't quite done before. But if you know calculus, draw pictures, set it up. You know something or other. Question? Yeah?
Are all the sections worth the same amount?
No. Okay, here's the deal. The multiple choice first part's worth 30% of your grade. Multiple choice second part's worth 30% of your grade. The free response is worth 40% of your grade. Okay? And this is how we determine what your grade is. Because you notice that part 1 and part 2 didn't have the same number of questions in it. We do that for a reason. So if your paper falls out of the pile and we look at it, we can tell how many questions you bubbled in. We can tell whether it was part 1 or part 2 based on the number of questions. We're math people. We got brains. So that's why, on my test, I always make you put a version A or version B above your name. On the final exam, we don't. We just look at the number of questions and we know which version it is if it falls out. We try to organize this stuff. But it's 30% part 1, 30% part 2, 40% for the free response. And then for the free response, each question is weighted the same of that 40%. There's 5 questions, so, you can pretty much divide that out, and each one is going to be equated the same. Okay? Don't let this be the only exam you guys do. There was a lot of stuff that we didn't do on there. The limit as x approaches some kind of number and you got 1 to the infinity or 0 to infinity, the exponential types, or infinity minus infinity. These are non-L'Hopital rule types that you have to manipulate the algebra and do some logs and stuff to be able to turn a L'Hopital rule. Make sure you go back and practice some things. Do some more examples and more exams. You got until tomorrow evening at 5 o'clock that you need to be at your exam station. Study. Don't let this be the only exam. Good luck, and I'll see you guys tomorrow for my students. You're welcome.